Testing 1 2 3. Testing 1 2 3. Testing. Testing. I think we're ready to come online for a new day of streaming. Finally, if I'm not mistaken. Yo, what's up? Welcome back to Vencabot. Intro to Python as a first language action. My name is David. Yo, today we're going to be going over the very basics of programming with Python as our lens. That is to say that we're going to talk about the essential concepts that you need to know to be a computer programmer for your very first program. And our language of choice is Python. That's my favorite language of all time and an excellent one for beginners. Before we get started, though, let me go here to Chrome. I want to actually close this and this and this. But I do want to show you guys that we're enjoying the music of my friend aubdat.bandcamp.com. That's aubdat.bandcamp.com. Kind of in the background very softly here. Just was not totally silent. Very cool guy, good friend of mine, and in my opinion, a genius ambient composer. His music is available for free at his Bandcamp page. That's aubdat.bandcamp.com. Free music in FLAC format or MP3 or OGG, whatever you want. He has a new album out, Aux Victimes, or Victimus. Really cool album, little EP there. Go check that out, guys. Plus, also follow him on Twitter at TC640B, at TC640B. Alright, so, if you've been watching our past streams, we've been working on like a little RPG with my friends Undead Kaiju and Jetstream Justin, neither of which are able to make it today, it seems, which means that I figured today why don't we take this opportunity to start a new program, right, and kind of go back and review the very basics, start from scratch, and kind of, if you guys are just starting now, it's a good place to start. Let's see what we got here. Okay, so the first thing you gotta know about programming is you need to have the Python interpreter if you're gonna be a Python programmer. If you want to learn how to do all that and set up your command prompt, as you see, I have this one here. You might want to check that out in the very first video. It's the start of our first episode. We talk about getting the command prompt and installing Python. We're not gonna go over that right now, I don't think. But we're actually going to clear this. Let's see here. Okay, so we're going to start right here with a blank command prompt in our Learning Python folder. We have a Pokemon Day1.py in Notepad. The .py extension is pretty important if you want to run your Python scripts a little bit easier later on. I recommend that you name your text files with a .py extension. Let's say the end of the file name should be a .py. We're calling this Pokemon Day, but so we're going to make like a Pokemon clone, I feel like, right? Or at least start one. I think Pokemon's a game that a lot of guys are familiar with. It's a good place to start if you want to get an idea of the very basics of how we're going to be using data and moving it around. So guys, the fundamentals of programming, I feel like there's two pillars, right? You have on the one hand data, which is your information you need in your program. Say if you're talking about video games, if you're playing Sonic the Hedgehog, right? You might need to know Sonic's position in the stage. That would be data, right? You might need to know how many rings he has. That would be data, right? You also need to have operations. That's the other pillar, right? You have data, you have operations. Operations are things like moving Sonic, right? So the data is, what you know, and the operations are how you use it, right? So you might have Sonic's position as your data, but now you want to move Sonic as an operation. So you have to change that data. You have to adjust his position, right? See what I'm saying about that? So first, let's talk about data. Right? The very first thing we're going to do in our program is what I call an assignment, right? An assignment. That means you're going to assign some data to a value. So just name whatever value you want. Let's just make a value here like, I don't know. We'll call this, Pokemon attack power, right? So we're going to have one Pokemon on our team. It's going to have some attack power, right? So I'm going to give it an assignment. We're going to use the equal sign. And we're going to say, his power is equal to what? Let's say, 18, right? Just making that up off the top of my head. Doesn't really matter. Here's our first line of code, right? We have some data here. The number 18, we're giving it a name, right? We're giving this 18 the name Pokemon attack power. That means later in our code, we can say, hey, how much attack power does our Pokemon have? Well, he has 18, right? That's where it's our first line there. I want to stress that we can call this, Pokemon attack, or Pokemon, damage power, or whatever. It doesn't really matter. We get to choose all the names of our variables when we're programming, so it's kind of cool. As long as we remember what our variable name is, we're fine. We're going to call it Pokemon attack power, though, to be explicit. Likewise, because we're the programmers, right, we can choose whatever value we want. We can give them fucking 100 attack power if it would please you, or 10 billion attack power. I don't think you want to use a comma there though, like that or something like that. So it doesn't really matter. We're the programmers. We can do whatever the hell we want. Hey, what's up, Kenny? How's your day, dude? We're gonna give him 18, I think, just because it's kind of a low, simple number to keep in mind. So there's our first line of code, guys. I'm going to save my program. And I'm going to go here to my command prompt and run the program. Okay, so here's our command prompt. In order to run a program in Python, you type in py, and then a space, and then the name of your script or your program. So I'm going to call this, what is this, a Pokemon day1.py. Here we go. Hit enter, it's going to run. Boom! Jack fucking nothing happened. Right, nothing happened because although we have data, right, we don't really have any meaningful operations. Remember that, guys? On the one hand, you have your data, which is your, the state of your program, all the things that are important to your program, your characters, your environments, your HP, and whatever the hell you want in your game, your ammo count. That's all a bunch of data. But in order for the program to do anything, it has to have operations, right? You have to use that data in a meaningful way. So right now we have an assignment that has no operations on it. So that's cool. We have some data, that's all we have. So how are we going to use this data, guys? Well, one thing we can do is we can show it to the user after they run the code, right? So let's just go down a line. Right? All programming code is read from top to bottom, as long as it's flush with the left-hand side of the screen. So you can see it's pretty flush with the left-hand side here. And we're going to do a very simple print operation. So we're going to run this function here called print. And whenever you run a function, you use quotation marks. You use parentheses like that. And when you use a function like print, between the parentheses, you put in what we call an argument, or what you want that function to operate on. So we have print here. We're going to print off our Pokemon attack power as our argument. Okay, so here's what we're saying here, guys. In the first line, we're saying this Pokemon attack power is equal to 18. All right, so we've assigned this name to this value. Now the second line, we're saying, now print off. In this case, when you say print in programming, you usually mean you show it. You don't necessarily print out a printer paper or whatever. We're going to show this value, the Pokemon attack power value. Right, so we've got two-line program now. Let's see how this works. All right, let's run this program again. Boom. Hey, look at that. Now something happened, right? We got 18. Right, the first time nothing happened. We had no interesting operations going on. We just had an assignment. But the second time we ran the program with that print statement added, or the print function, now we have 18 gets printed onto the screen. That's kind of cool. So Kenny's been working on his program as well. He's been messing with my 3S ROMs a little bit, huh? All right, so you've been messing with the ROM, huh? How do you mean, Kenny? What kind of changes have you been making to your ROM? You fucking hacker. Okay, so let's review this simple two-line program that we just wrote. Right, on the first line, we assign a variable. Right, so we named our data, Pokemon attack power, or our variable, and then we assigned some data to that name. So we said Pokemon attack power is equal to 18. In the second line, we printed off Pokemon attack power. Right, so that's why we get the 18 that comes out, because this is equal to 18, right? Now we can also print off all kinds of crazy shit, man. We could print off, we could print off, 800. Right, just a raw number. We haven't assigned that number to anything. We just punch in the number right there. So let's see what happens. Okay, let's go back here to the command prompt. Boom, 800. Right, it just prints off that number for us. Now let's try and print off something else. Right? We've been using a lot of integers, right? That's to say like a whole number like 18 or 800, an integer number. Let's try to print off like, Pikachu. Right? See if we can print off the word Pikachu here. Okay, let's try this program now. Oh, fuck, guys. Our first error. Oh, my God. What have we done? So we got this error message here. It says in line 2 of our program, so file Pokemon day1.py, on line 2, we have this statement, print Pikachu. I remember that, right? That's our line 2, right? Print Pikachu. Let's go double check. Yeah, so that is our line 2. So we have an error on line 2. What's our error? Name error. Name Pikachu is not defined. Fuck, you don't know who Pikachu is? It's a pretty popular character, right? No, it's just because when you write in a arbitrary word like Pikachu, Python assumes it's a variable name, like Pokemon attack power, right? You can see they're very similar. It's all just some text there, Pokemon attack power and Pikachu. But Pikachu, we never did assign Pikachu. We never did like Pikachu. Let's say this. I'll say Pikachu equals 12, right? There you go. Now we assign Pikachu. Now what happens? Oh, well, now we got 12, but that makes sense, I guess. It's not really what we wanted, though, right? We wanted to print off the word Pikachu. But yeah, so when we say print Pikachu, it means print off the variable with the name Pikachu. If we have no variable named Pikachu like this, we get an error. If we want to print out some text, we need a new data type. We've been working with integers, right? Like numbers, like 18 and 800 and stuff. But now we need a textual data type. In Python, you do that by using quotation marks. Boom, like that. Then we can say Pikachu. Boom. All right, so now we have some text there, right? If we just used Pikachu, it's a variable name, and we don't have that variable, so we get an error. If we use quotation marks, now we're talking about textual data. Let's try this. Okay, so now we got Pikachu to print off, right? So that makes sense. So in Python, we've now learned two types of data, right? We have integers, like 18, and we have what we call strings. In most programming languages, textual data is called a string. I'm not exactly sure why. I think it's like a string of characters. But yeah, so we don't call it text, we call it a string. And yeah, there's our textual data, our string Pikachu. What I missed in the chat here. So Kenny says, I've been messing with the 3S ROM a bit. I zeroed out the bytes in the first half of the 51 file, tried my best to briefly look what it did, and try to figure stuff out. What happened, man? Did it make a lot of characters have no colors or what? Here goes says, change Pikachu to a better Pokemon, like a Machamp, huh? Here goes, has very strong opinions about Pikachu sounds like. What's up, Eric? He says, oh my god, it's Python. Yeah, cool guys. So we've learned already a lot. In these 2 lines of data, we've learned a lot. We've learned a lot about the 2 principles of programming, data and operations. We have 2 kinds of data here, an integer on line 1, 18, and a string on line 2, Pikachu. Right, here we have a variable name. Right? Pokemon tag power is our variable name. And we use the assignment operator, aka the equal sign. Because it assigns things, it's an operator, it does something, it assigns stuff. And then here we have this entire line here, Pokemon tag power, the name assigned to the number 18. On line 2 we have an operation, it's a function. Print is a function, you can tell because it has these parentheses around it. So we have a function that means do something, right? This is a simple assignment, this says, hey, do something. And then our argument for our function, that is to say the data the function uses to do its job, is put between the parentheses. We're going to put a string in there, is Pikachu. Boom, wow, we're amazing programmers now. Eric says, I honestly didn't enjoy learning Python for some reason. You don't think so? I fucking love Python, man. Python to goud. Okay, so now we've done, we introduced some very basic programming concepts, right? Let's do something more interesting. So why don't we use this attack power we made? Right, so first of all, let's say, instead of saying Pokemon attack power, let's say, our Pokemon, attack power. Right, it's 18. Now we can say, enemy Pokemon health points. Oh shit, let's give him, I don't know, 56 HP. Who cares? So now we have another variable here. I'm going to get rid of this print lines. You don't need this print Pikachu. It doesn't do anything, right? It just prints off the name Pikachu. But now we have 2 assignments, right? We have our Pokemon's attack power is 18. We also have an enemy Pokemon now, so we have 2 Pokemon in play. Our Pokemon and their Pokemon. He has health points. It's 56. Okay. So let's do a couple things first. Let's print off our Pokemon's attack power. All right, so we're going to print off our Pokemon attack power, which looks back up to here. It says, hey, what's the attack power? It's 18, right? So we're going to print off 18 here, as you guys probably have figured out by now. Then we're going to print off, print enemy Pokemon health points. As you guys know, it's going to reference this line here, and it's going to say, oh, that's 56. We're going to print off 18, then 56, right? That's what I think is going to happen. But who am I? What do I know? Boom! 18 and 56, wow. But now what's going to happen? Oh, my lord. We're going to actually make a little action happen here, right? So now we've done this printing statement here. We're going to actually do damage to the enemy Pokemon. So we're going to say, enemy Pokemon health points is equal to enemy Pokemon health points. All right, well, that doesn't do anything, right? It's pretty redundant, you would think, right? So now we've just said, hey, listen, the enemy's health points are equal to the enemy's health points. Right, so it's going to say it's 56, right? This means 56. So we have no, but wait. We're going to actually subtract our Pokemon's attack power. Okay, so look at that. So now we're saying, what are we saying here, guys? The new value of enemy Pokemon health points is equal to what it was, 56, minus our Pokemon's attack power, 18. So the new value is going to be, 18 lower than 56. I'm not a mathematician, guys. I'm not paid to do that, so I don't know what that value is. We're going to find out, though. Let's figure out what that is now. So we're going to print off, enemy Pokemon health points again. Right? So I have, 1, 2, 3, 4, 5, 6 lines of code. Now we're getting somewhere. So let's see what happens now. Okay, so now we got 3 values printing off, right? We print off 18, 56, and 38. So let's look at why that is. So we still print off our Pokemon's attack power right here. All right, that's 18. So as we read the code from top to bottom, when we run Python, Python reads each line from top to bottom and executes it. So the first thing it does is it assigns our Pokemon's attack power to 18. Then it assigns some enemy Pokemon health points to 56. Now we print off our attack power, so we get 18. It shows up on our screen. We print off the enemy's Pokemon's health points, so now we see on our screen 56. And then we do some mathematical stuff here. The enemy Pokemon's health points is reassigned. That value is now changed. It's the same name, but new value. And now it's, the old value here minus our Pokemon's attack power. So that Pokemon just got attacked, basically. Right? And now we print off the enemy's new health points. Now he has, what would we say, 38 attack power, or 38 health points left. So he had 56. We did 18 damage to him. Now he has 38 left. Lord have mercy. We already got a game, basically. Kenny says, I've enjoyed learning Python. Definitely a bit different compared to the other languages I've messed with, though. It is very different. Python's very flexible, for better or worse. It can be kind of, if you're used to more static languages and things that are a little more rigid, it can be kind of an adjustment to get used to Python. Okay, so let's, add some lines here. Here says, let's go to fighting game, huh? We'll do that. I mean, sure, we can do that if you want. Yeah, so we can do, well, I don't know. I don't want to do that because I think a lot of our viewers on YouTube are not as familiar with fighting games as they are with Pokemon. But we'll do that later on for sure. We can talk about frame data and, hitbox and stuff like that. But I think the Pokemon's much more familiar to a lot of people. It's called something cool, huh? What's the fighting game going to be called? Here goes. Our future fighting game. Like King of Fighters. Wow, King of Fighters. I don't know why nobody thought of that before. It's a pretty cool name. You're the king of all the fighters, right? You're the winner. And it has all kinds of symbolism in it. So let's print off some more stuff, guys. Right now we have, 3 lines with a bunch of fucking text, right? Excuse me, with a bunch of numbers. This means nothing. I'm going to clear the screen here with CLS. Clear screen. Boom. So we have, excuse me, I want to print off. So we have these 3 numbers print off. There's not a lot of information there, right? We don't know what the hell these numbers mean. Let's make it more explicit to the user by printing out some text. So we're gonna, before we, let's put all of our, our variable assignments. No, actually, I'm gonna put a little blank line here to split apart the variables from the print statements, right? Boom. So now we have these assignments here and here, and an assignment here as well, and the print statements in between. But we're gonna make another print statement here. So after we assign our enemy Pokemon health points, we're gonna print off some text, or a string, so to speak, right? We're gonna say, our Pokemon's attack power is, okay, then it prints off the attack power, right? I'm gonna say, enemy Pokemon's HP is, then we print off their HP. Then we're going to kind of explain what's going on here, right? So we're going to print, after this statement here, after this line, where we've changed the enemy's health points, we're going to tell the user, our Pokemon attacked the enemy Pokemon. We're going to print off, the new health points. So print enemy Pokemon's new HP is. All right, let's see what happens here. See if I punched that all incorrectly. Boom. Oh, I got syntax error. I did something wrong. Let's see here. Line 8. Invalid syntax. Oh, that means I typed in something in the wrong order. Let's see, let's double check what we got wrong here. Aha. I missed a quotation by parenthesis right there. Boom. Whenever you open a parenthesis, you gotta close it, man. gotta close it. That should work. Here we go. So now we got some data, right? We got some more information what's going on here. If we printed off our Pokemon's attack power is, then we printed off the value. We say that any Pokemon's HP is, then we showed the value. Let me explain that our Pokemon attacked the enemy Pokemon. Now the new HP is 38. Okay, so now we've got a nice little log of what happened in our program here, huh? What's up, Echo? How you doing, man? Here goes says, I tried to design my own fighting game, but ended up too similar to Yatagarasu, so I just gave up. What's wrong with that? Nothing wrong with cloning a game that you love. If you love a game, try to make something similar. Maybe over time it will develop its own identity, right? As you work more and more on it. But yeah, I don't see what's wrong with designing a game that's similar to another game that exists already. Okay, so let's review what we've done. What have we done? My lord, what have we done? So we assigned a couple of variables, right? With the assignment operator, here the equal sign is the assignment operator. It says, hey, here's the name we want. Give it this value. So that in the future, if we use this name, we know we're talking about this value, such as right here. Right? We used the name, but we know it means 18. Python knows it means 18, so it prints off the number 18. We're also using two kinds of data. We have integers like 18 and 56, as well as the integer that results from this operation. Right? We have the subtraction operation that returns a value. So it gives us a value of 38. That's an integer. It's basically, this whole thing basically counts as an integer. We also have strings, textual data, like right here. Starts and ends with quotation marks, so you know it's a string of text. So Python knows, I should say. We have one there, we have one here, and we have a string right here. Very important for, showing the user some textual data so they know what the hell's going on. Echo says, I rated you, ended up with 1 view out of 5. I'm sorry, it's okay, Echo. I'll forgive you. I appreciate it, though. I appreciate it. Here goes says, because Yada is very much King of Fighters' third strike, and that's exactly what my shit ended up being, LMAO. Again, that's pretty cool. Sounds cool to me. You might be able to make your own characters and stuff. I mean, yeah, it might have the same mechanics, but if you design your own game, you could design, some new characters and cool stuff like that. In our case, we have no characters yet, right? All we have is a couple of random attributes. We have a Pokemon attack power and enemy Pokemon health points. Right? So now that we know how to use strings, why don't we give Pokemon some names? Right? Let's use a string. Let's say, our Pokemon name equals Pikachu. Right? He's so godlike. How can we not use Pikachu? But the enemy Pokemon name is going to be Machamp. Because our opposing trainer, I guess, is our friend Here Goes in the chat. All right, so now we have a couple names, right? We have some assignments to some variables, and they are assigning string data, right? We have some string data here. So now the first thing our program does is assign some names, but there's no, we don't ever print these names, so we don't get to see what's happening. Our program still looks the same on the outside. But on the inside, we assign these names. Then we assign some integers, some Pokemon attack power and enemy Pokemon health points. Print off some data for our users so we can see what the hell's going on the outside. Then we do an operation here where we subtract the enemy's health points. So we subtract our Pokemon's attack power from the enemy health points, so it's like, they basically hit them. Then we explain what just happened to the user. In fact, I could even probably bring this a little bit closer. Like that. And let me explain the enemy's new health points after he takes damage. Right, so how are we going to use these Pokemon names? Well, we could use the string addition operator, right? So here's what we're going to do. Instead of saying our Pokemon's attack power is, why don't we add some strings together? So why don't we say, our Pokemon name plus, attack power is, right? Actually, I'm going to get rid of this. Okay, so now we're adding some strings together, right? We're adding Pikachu, our Pokemon name Pikachu, to this string, attack power is. So let's see what happens there. You would add numbers together, you can add 1 plus 1 equals 2, but you also add two strings together to combine them. Let's see how that looks. Okay, well here we have it worked, kind of, right? Pikachu, attack power is. But when you add strings together, they add them right together. Right? So as you can see, we have this weird word here, Pikachu attack power is. So we have to go back to our code. When we add these strings together, so right now we have Pikachu as the name, right? Let's put like, apostrophe S space. Right? So now we have our Pokemon name, Pikachu, plus apostrophe S space attack power is. All right, so let's see what happens now. I'm going to clear the screen here so I don't get so close to the bottom. Boom. Hey, now we're talking. Pikachu's attack power is 18. Enemy Pokemon HP is okay. That's kind of cool. Pikachu attack. Is that like anything like chicken attack? I don't think so. Could be some similarities, but more or less Pikachu's pretty different from chicken. Here goes says that the only characters I had were functions that I thought would be cool, like Alex plus Clark. I thought you said Clark was Alex. Hugo, Kyo, Iori, Ken, a Chun-Li, and a Guile. What defines a Chun-Li? Here goes says, here, had all the frame data worked out too, but I just gave up, huh? You fucking quitter, Here goes. Come on, dude. I never quit a project ever. I've never quit a project. No, I quit it all the time, dude. It's harder than you would think. Anyway, so let's change this statement here too. Enemy Pokemon's HP is. Let's just say, you know, apostrophe S HP. We're gonna add in another string, right? We're gonna say enemy Pokemon name plus this other string. So we have, you know, two strings here being added together and two strings here being added together. But you'll notice that they look kind of different, right? This one is a variable name that refers to a string, right? Right here you see it refers to a string. And this is an actual string. There's no variable right there. It's just a straight up string. You can see it. In Python and most programming languages, we call that a literal. So here we have a variable, and here we have a literal, right? So this value, we can't tell what it is from looking at it, right? We can't tell what this means at first. We have to go look for what it means up here. Our Pokemon name is Pikachu, right? But here, it's very plain what it is. It's literally just this data. This is a literal. So in this case, we have a variable name, and we have a string literal. We have a variable name right here as well. It's being assigned to a string literal. Here we have another variable name, our Pokemon attack power, being referred to an integer literal right here. And likewise, we have the enemy's Pokemon health points being referred to, it refers to a integer literal right here. Also here, we have a variable name, enemy Pokemon health points. But we're referring not to a literal and not to a variable either, but to an entire operation. Right? So this variable is equal to the output. Whatever, you know, when this operation runs, when we subtract the Pokemon attack power from the enemy Pokemon health points, whatever is the result is the new value of this variable. So those are basically the three ways to show data in programming. One way is to just show a variable name, such as, you know, right here. One way is to show a string literal, or excuse me, a literal value, like here, string literals, or here, an integer literal. And the third way to show a value is to execute an operation, like this. And the value you get is whatever the result is. Right, so there are three ways that you can show data. Kind of cool, right? Here goes says, Clark is better Alex as much as it pains me to say. Well, nothing wrong with that. Okay, cool. So let's see, well, we still have one more line to change, right? This, our Pokemon attacked the enemy Pokemon. Why don't we say, you know, we'll get rid of all this text. We'll say, you know, our Pokemon name plus, you know, attacked. Then we're going to say, you know, who did they attack? They attacked the enemy Pokemon name. We're going to add in an exclamation mark as well. There. And then here on this last line, we're going to say, instead of saying enemy Pokemon's new HP is, we're going to actually use the enemy Pokemon's name for that. So we're going to use enemy Pokemon name plus new HP is. Okay. Let's see what happens now. Our code is getting way more interesting, right? Let's see what happens here. Boom. I got the invalid syntax. I'm a loser. See, I missed a plus sign right there. So invalid syntax means you fucked up typing something. That's it. So syntax is, you know, it's like grammar. Here's our invalid syntax right here. So in this little bit right here, we have, you know, variable name plus a string literal. Then we have no plus sign here. So that's our problem. Boom. Now we're talking. All right, so let's go back over here. Hey, okay, so now we have this whole situation. Look at all this new code we have here. Look at this output. So we know Pikachu's attack power is 18. We know Machamp's HP is 56. Pikachu attacks Machamp. Machamp's new HP is 38. What's up, last Vec A? Are you making game using Pygame? No, no, no. This is our very first day programming, dude. We're gonna mostly just be using text. Yeah, not Pygame. Pygame is a much later on kind of thing. This is like basically our first program together as totally novice programmers. Welcome aboard last Vec. Not sure I pronounced that correctly. I'm sorry if I didn't. Okay, so let's talk about why we use variables. Right. So here's what's kind of cool about this. We could have also just punched in like manually, like, you know, we could just, instead of saying, you know, our Pokemon name attacked enemy Pokemon, we could just say this. Watch, we could just easily say, it'd be shorter too, right? We just say, you know, Pikachu attacked Machamp. Right? That's the same exact thing. Why even use all these big variables? Right, let's go run this code. It's going to have the same output, right? Yeah, it looks exactly the fucking same. But here's why variables are really cool. Because we can go to this first line here and change it to, you know, Eevee and Squirtle. Right, save it. Then run it. Right? Look at that. See, so it says Eevee's attack power is 18. Squirtle's HP is 56. Pikachu attacked Machamp. What the fuck? Squirtle's new HP is 38. So by using a variable instead of just a literal, right here we're using literals, right? Pikachu and Machamp. By using variables instead, let's say, you know, our Pokemon name plus attacked, you know, the enemy Pokemon name. Exclamation point. Now, every time we use this variable, our Pokemon name, or any Pokemon name, it refers to that same value. So we could actually use that value in a ton of places in the code and have it change just with one simple change. We could have it be, you know, I don't know, who's a Pokemon? Charmander versus, you know, Zubat. So we can easily change their names, and now every line of code that refers to their names is also effectively changed. That's really, really cool. So now we have Charmander fighting Zubat, because all we did is change that variable. I'm going to cough, guys. I apologize. So here goes once Machamp to Itachi Gaigus, huh? That's a fighting game reference. Let's close the clear the screen here. We can do that as well. So all we got to do is we can make Machamp. We can make Machamp. We'll go back to our, you know, our first Pokemon. We'll do Pikachu and Machamp as their names. So we're gonna make Machamp attack back. Right. So now we have Pikachu attacking Machamp. Right here on this line. So now we need to give Pikachu some health, right? So let's you know, put some blank lines. In Python, blank lines are pretty much meaningless, so you can put in as many as you want. I've been using some here to try and make it look a little bit more readable, trying to break it up in a logical way, but you can use blank lines as many as you want. It doesn't really matter. In my case, I'm going to actually put any Pokemon's attack power right here. We're going to give him, he's Machamp, but he has an insane attack power. Let's give him fucking like, I don't know, fucking like 30, 34 or 35, yeah. And then we're going to give our Pokemon some health points as well. That way, Machamp can fight back. So Pikachu's gonna have what? Probably less HP than Machamp too, right? So let's give him like, I don't know, like 40 health. Defense, I preferred the potential typo there. A Polkamon. Okay, make some Polkamon. You have a little dance fight instead. How you doing, 3Revenge? How's your night been? All right, so now we have enough information that we need to have Machamp attack back. Right now, Machamp has his own attack power, and Pikachu has his own health that can get subtracted. So now we can add some more lines down here, right? Now we can say, you know, our Pokemon health points is equal to, you know, our Pokemon's health points. We're saying right now that our Pokemon's health points are equal to 40, because this is what that refers to, right? Whenever we say our Pokemon's health point, we're referring to the number 40. But we're saying that the new value of this is going to be, you know, our old health points minus the enemy Pokemon attack power. Right? So it's very much like this line right here, but the opposite. On this line, we have the enemy Pokemon's health points is, has the our Pokemon's attack power subtracted from it. On this line, we have our Pokemon's health points is being reduced by the amount of enemy Pokemon attack power. All right, so we have 40 is our Pokemon's health points minus 35. Holy shit, Pikachu's almost fucking dead. What a scrub. Level up, Pikachu. All right, so let's basically use the same line as well right here. Print enemy Pokemon name. That's what, Machamp. Plus, he does a Tachigaigus. That's the name of his attack. Tachigaigus. Our Pokemon. Right? An exclamation mark there as well. Okay, so now we're going to print off, our HP. So we're going to say, our Pokemon name plus new HP is print our Pokemon health points. So you're starting to see that there's a lot of repetition here, right? Like these 4 lines are basically repeated, right? These 4 lines right here are repeated right here, but just reverse, right? Instead of having the enemy, instead of Pikachu attack the enemy, now Machamp's attacking Pikachu, right? But the code is very similar. It says we're changing some, we're replacing some values with other ones. So now we have a much more elaborate program here. Now we're Machamp's fighting back. Let's see what happens. Oops, excuse me, I don't want to do that. Okay. So yeah, so we have Machamp's, we have Pikachu's attack power is 18, and Machamp's HP is 56. Pikachu attacks Machamp. Machamp's new HP is 38. Machamp Tachigaigus Pikachu. Pikachu's new HP is 5. Look at that. So we have like a little bit of action already, right? We're our first day programming, but we already have some action going on here in our game. 3Venge says he's doing okay. Midterm grade is looking decent if the midterm next week goes smoothly, and usually your tests aren't too difficult. So sounds like it's not going to be too bad, I hope. I think you're going to be okay, 3Venge. I know you're pretty smart guy. You work pretty hard. Pikachu got wrecked. He did get wrecked. Again, we're fighting Machamp here. It's not a fair fight. But yeah, so right now, Machamp, he's got 38 health left. Pikachu's already down to 5. We got a pretty bad situation here for Pikachu. Okay, so let's review what we've learned here in this very simple program. We've got some variable assignments. So we're assigning things like our Pokemon's name to a string literal. We're assigning things like our Pokemon's attack power and their health points to some integer literals. And we're printing off some information. That is to say, we're showing the user on the screen some text here by adding strings together. Like our Pokemon's name is a string. We're adding that to this string literal to get some like dynamic sort of text on the screen. We can change it to something changes in these words here. We're also printing off some integers, right? We're printing off just a raw integer here. Our Pokemon's attack power. So you can print strings, or you can print integers, or you can print all kinds of cool data as well. But you have to make sure that if you're printing some things that are added together, they have to be the same type. So we can add strings to strings, like right here, but we cannot add a integer to a string. I'll demonstrate that. So let's say, our Pokemon name plus his attack power is plus our Pokemon attack power. Right? So I'm going to get rid of this line down here. So here we have a string, our Pokemon's name. As you can see right here, it's a string. Being added to a string, this is a literal, you can see that string right there. But we're adding that to our Pokemon's attack power. Right? And that is not a string, that is a fucking number. What's going to happen, guys? We gotta find out. Ah, shit. We got a fucking error message. It's right there we thought it was going to be, right? It says, can only concatenate, that's a programming language for add. Concatenate means combine or add. We can't combine a string, well, we can only combine a string, not an integer, to a string. So we cannot add integers to strings, so we fucked up. Echo says, you making your own kind of game? No, we're kind of making like a Pokemon clone here. At least today, Echo. We're kind of making like a little Pokemon game here, a little bit. It's basically our first program ever, so it's pretty simple. But nothing wrong with that, though. Simple programs are a great way to learn. All right, so we can't add this number to this string. Well, shit. Well, we can do what we did here, right, on the second line, what we'd be doing so far. We'll just print that on a different line, right? We'll print off, our Pokemon's attack power right here. That way we're not adding it to any integers. If we can print strings, we can print off integers, we can't print them together. So we can just print them separately. That's one solution. Let's review that again. Okay, that looks cool, I guess. We got this, attack power is, there's a string, then we print off the integer on a separate line. All right, that's all well and good, I guess. Then we have the Machamp's HP, that's a string. Separate line, we have the integer. But here's what we can do. Why don't we use a function? Right? Python has built-in functions. It has cool things you can do with data. For instance, we have this print function right here. Right? We've been using print. We got there's the start of it, and here's the closing of the print statement. Here's the argument in the middle. We discussed that earlier, right? You have a function. It's got a quotation mark, so you got parentheses around it, or at the end of it. And then between the parentheses, you put in the arguments, which are what that function needs to operate. Right? So we've been using print. There's another one we can use too, though. You guys ready? Why don't we use a function to convert, or let's say to express an integer as a string? So we can't add in, our Pokemon's attack power. You cannot add a integer to a string. But if we use this function, str, okay, then use our Pokemon's attack power as an argument, we can temporarily show that integer as a string. So str will take any kind of data, like an integer, for instance, and show it as a string. So now we're adding, a string here to a string here to a string here. Remember how I said that you can express data as the returned value of an operation? Like right here, for instance, right? We have our Pokemon's, the enemy Pokemon's health points right here. And it's not equal to a literal value, like, 18. It's not equal to a single variable. It's equal to whatever value is the result of this operation. That's the third way to show data, is, as a result of an operation. Here's an operation right here. It says, return the string version of our Pokemon's attack power. Right? So let's see what happens here. Actually, I'm going to get rid of this line down here. Okay. Oh, look at that. Pikachu's attack power is 18. So this line right here, this little bit right here, it temporarily converted our Pokemon's attack power to a string value. It turned it basically from, it turned 18 into 18, right? So we have this number 18, turned it into a string literal of 18. So that's pretty cool. That's what string does. Now we know two different functions, right? We know the print function, right? We know how to use print. We know how to use string now. So string will turn data into strings. That's fucking sick. Welcome aboard, Anatzum. CLI game showcasing intro programming topics, it looks like. Just got here, so you're right, dude. You're right. Welcome aboard. Sorry I pronounced your name wrong. Anatzum. We're going over the very basics of programming here by writing a very, very simple game. Very, very simple. Well, that's cool, but we have a kind of a problem, though, right? Let's go over here. Look, there's no space right here, right? It's kind of annoying. Let's fix that. We're going to fix that by going to our program and adding a space right now. Okay. Let's do that same idea on this line. So enemy Pokemon's HP is space. We're going to add in the string version of the enemy Pokemon's health points, because again, we cannot add an integer to a string. But if we're using the string version, that works. Maybe we can add a string to a string, no problem. All right, we're going to do that on this line as well. We're going to add in the string version of enemy Pokemon health points. And then get rid of this line. Don't need that print statement anymore. We're going to use one last one right here. We're going to add in the string version of our Pokemon's health points. I know I'm talking fast, guys. I'm going to review this real quick after this. And we're going to kind of go back and look at what we've done. My God, what have we done? Okay, cool. So now we have all of our... We pressed our lines a lot, right? No more of these blank lines with just one integer on them. Because now we're using the string version of that integer to add to the other strings. We can have it be on one line. Good Vibe says, I want to see Chun-Li's power data. This is a cool idea. I'll need to set time to watch this from start one time. Yeah, it'll be on YouTube starting, a couple days from now, guys. Echo says, you make me want to play Pokemon now. I have an idea of something that I like to do, but I'll speak about it with you somewhere. Okay, cool stuff, Echo. Anytime you want to get a hold of me, you can get a hold of me on Discord or here on Twitch or wherever you like. Okay, so let's clear the screen here. There's a lot of text. Before we go on, we still have quite a lot of time to program here today. Let's look at what the fuck we've done. We got quite a lot of code here now, right? Look at all this fucking code we have. What is it all doing? Well, first of all, we're assigning a bunch of data, right? Again, programs are basically made up of two ideas. The data, which is the information that you need for your program to run. Then you have your operations, which are the actual program running, like actually doing things to that data. Right? So in Pokemon, your data might be your attack power and your health points. And an operation might be an attack. Right? So the attack needs that data, right? The attack is the part that you want to do, but you can't do it without the data. So first thing you do is you define some data right here. The start of, again, Python reads from top to bottom. So basically this all happens in order. First thing we do is we define a name for our Pokemon and for the enemy Pokemon as strings, right? As textual data. Then we start defining some numbers, some integer data, right? We have our Pokemon's attack power, enemy's attack power, our Pokemon's health points, enemy's health points. In fact, because nothing is actually happening yet, there's no operations, nothing important's happening for the user to care about, we can do these in any order. We can define, the Pokemon's attack power first if we want. Let's cut this and then paste it up here. All right. So this doesn't matter. It doesn't matter what order we do this stuff in. We're just defining a bunch of assorted data, right? In fact, why don't we do this? Why don't we group our data just for our own pleasure based on which Pokemon is which? So we're going to define our Pokemon stuff first, right? Just for our own pleasure, make it more readable. Then we're going to give, the enemy Pokemon his stuff. So what have we done here, guys? Well, we've reorganized our code. We've changed the order that things happen in, but it's only the assignment, so it doesn't really matter. So now, right off the bat, we define our Pokemon stuff, right? Our Pokemon's name is Pikachu. He has 40 health points. He has 18 attack power. Then we define our enemy Pokemon stuff. His name is Machamp. He has 56 health points. He has way more attack power at 35, right? So we're reading the code from top to bottom, just like Python would. Then we start printing off some stuff, right? You print off our Pokemon's attack power, print off our Pokemon's enemy Pokemon's HP, print off the fact, then we do an operation here, right? So I'm actually going to combine these into one little group to make it easy to see what's going on here. All right, so here we have the actual combat starting, right? The enemy's health points get reduced. The enemy Pokemon's health points becomes equal to, we're changing the value of the health points, what it used to be, minus our Pokemon's attack power. All right, so now he's losing health points equal to how much damage our Pokemon does. Okay, so he's taking damage, right? He's lost health. So we tell the user that, right? Okay, we can get rid of all these prints. Let's actually, just to demonstrate, I'm gonna actually, in Python, you put a hashtag or a pound or a number sign, whatever you want to call it, before a line. That means that line is ignored by Python. Nothing actually happens. So we're ignoring all these print statements now. Nothing's happening. All right, we're putting these pound signs in here. That says, don't even do this. Don't fuck with this. Don't worry about it. All right, so really all we have now are these lines and this line and this line. All the lines that start with a pound sign or a hashtag or a number sign, those lines are ignored. So because we don't ever print anything, the user doesn't see anything, right? Nothing happens. What am I missing in the chat here? So Last says, make a random value on attack. Yeah, we're going to do that at some point, Last Vec. I'm looking forward to that. But again, since our first day programming, I'm not going to fuck around with any kind of extra libraries or functions if I can avoid it. And Ed Zum says, use TK any? A little bit, not very much. I'm not really into GUIs that much, to be honest. But we could definitely do that at some point here on the stream. In any case, I think for our first day, it's kind of cool to use just text. Speaking of text, guys, again, because we saw nothing doesn't mean nothing happened. Right? We ran this code, we saw nothing. But look at what happened behind the scenes. We defined some data, right? Machamp got attacked right here. We didn't see it, but he did. And then Pikachu got attacked right here. Again, we didn't see it, but he got attacked. Now, we can actually show the user some stuff by getting these print statements to work again, right? By getting rid of these number signs, which prevent that code from running. So now we're printing off, Pikachu attacked Machamp. We're gonna print off here, Machamp Tachigai against Pikachu. Right, so now we're showing these a little bit more stuff here. All right, there we go. Right, so now we've gotten rid of those little number signs. That code will run again. There you go. Again, just to remind you guys, if you start a line with a hashtag or a pound sign or a number sign, that line will be ignored. It won't run. That's pretty cool. It's for commenting, right? That way we can say, let's say this. Actually, let's use it to our advantage, right? Now, if I were to say it right here, let's just say we're defining data for our Pokemon right here, right? Let's try and run this code, see what happens. Oh, shit. Syntax errors. Well, why do we have a syntax error? Well, it's because it's trying to run that as code. It's trying to run this as code. It's like, yeah, what the fuck does this code mean? We're defining data for... That's not an assignment. That's not a print statement. What do you mean we're defining data for our Pokemon? What does that mean? Python doesn't know, right? Because it's meant for us to read, not for Python to read. It's for the human being to read. So we can use this number sign to say, hey, ignore that line. Just ignore that line, Python. Don't even worry about what that means. Right? That's for me and my friends to read, not for you to read, Python. So now Python is no longer confused by that. Python's like, oh, okay, so it's not really code. That's fine. I can just run the code now and ignore that part. So this pound sign, this number sign, hashtag, is used for commenting your code. That means it's easy for you to read as a human being, to know what the hell's going on. We're going to actually make use of that now, right? We're going to say, define enemy Pokemon data is for this chunk. Here we're going to define, our Pokemon data. Right, we're going to get all these statements back in business here. So all this stuff's printing off again. But now we can actually use comments, now we know how to use comments, to make it a bit easier to read. Break it up a little bit. So we're going to actually say, we don't need to know what our Pokemon stats are, right? Well, no, we'll do that. We'll say, show the user our Pokemon's, I don't want to keep capitalizing that, stats. So we're going to say, let's make a line for our Pokemon name plus HP is, so we're going to show, Pikachu's HP now that he has some HP. Our Pokemon health points. Okay, I think I did that right. Now we're going to print off, show the user the enemy Pokemon's stats. So we have his HP. We're going to show his attack power. He has that now. So we're going to use the enemy Pokemon's attack power. Excuse me, his name. Attack power is the string version of his attack power, right? Because if we use the integer version, like what it actually is, it won't add together. It'll cause an error. They can't add. You can't add strings to integers, so we had to turn to a string temporarily to show it there. Cool beans. Here goes says, man, I miss Yada. What a good game. I have only heard of it a few times. Is it really that good? Yadagarasu. Okay, so now we have, we're showing our Pokemon stats. We're showing the user, the enemy Pokemon stats. Now we're going to, our Pokemon attacks the enemy Pokemon. Right, that'd be these 3 lines. So you have the enemy's health points get reduced. We tell the user that, Pikachu attacked Machamp. Then we show them his new HP. Now we're going to say, the enemy Pokemon attacks our Pokemon. Okay, so now look how much more readable our code is. We have our code defined in nice little chunks now. We have 1, 2, 3, 4, 5, 6 chunks. We define our Pokemon data. We define their Pokemon data. We show the user, our Pokemon stats. We show them their Pokemon, the enemy Pokemon stats. And then, our Pokemon attacks the enemy Pokemon, then the enemy attacks us. That's our code right now. So let's run it and make sure it all still works. Sick! So we show them, you know, our HP, you know, Pikachu's HP, Pikachu's attack power, you know, Machamp's HP, Machamp's attack power, Pikachu attacks, we get some new HP out of that. Machamp attacks, we get Pikachu's new HP out of that. Cool! Why don't we add some blank lines for the user, right? We have blank lines for us. If we go here, we see we have these blank lines here, kind of break up the code a little bit, make it easier to read. Why don't we give the user some of that? Because we go here to the actual user side. It's just a big bunch of text to spit out, right? So here's what we're going to do, a blank line. We just used a print statement with no argument. So we're going to do this, watch. There you go. So we have this print function right here. And you know it's a function because it has this, these parentheses on the end. But it has no argument, right? There is no, you know, nothing between the parentheses for it to print off. So in Python, when you print with no argument, it just means print a blank line. We're going to do that after every important bit of code. That way the user can get some, you know, some visual distinction of what the hell's going on. So we have these blank lines now. That should make it easier to read on our side, right? Let's see if this does anything good for us. Hey, that's so much easier to read, right? Pikachu stats, Machamp stats, Pikachu attacks, Machamp attacks. What's up, Luffy? We've never heard of Yatagarasu? It's, I guess, an SNK fighting game. Well, neato kino, guys. We have our own little game going on here. We have a nice little, they take turns fighting. That's sick. But, how are they going to keep fighting? All right, let's go look at our code. No one's dead yet. Oh, it's not SNK? I didn't know that. So who is it? Here goes. Who publishes it? I really thought it was SNK. Who's the publisher of Yatagarasu? All right, so here's our problem, guys. Now, one thing we could do is we could just copy paste all this code. Let's do that first, right? We're going to copy all this code for our turn and the enemy's turn. And we're going to paste it down here. So we're going to say our Pokemon attacks the enemy Pokemon, you know, again. And the enemy Pokemon attacks our Pokemon again, right? So now we have longer code. As you can see, we've copy pasted the turns, you know, our turn here and the enemy's turn. Now we have our turn again and the enemy turn again. Let's see how this works. Okay, so look, we have got more turns now. So we have our Pikachu's HP at start and his attack power. We have Machamp's HP and attack power. So Pikachu attacks Machamp. Now Machamp has 38 health left. Machamp Tachigai's his Pikachu. He has, you know, only 5 health left. Pikachu attacks again. So Pikachu had, what, 18 attack power, right? So the first time he did 18 damage, he got 38 left. Now he did 18 more damage. Machamp has 20 health left. Then Machamp Tachigai's Pikachu, and he has negative 30 health. This guy's fucking dead. He's super dead. He's a fucking squash. He's a pancake. He's a bloody streak on the fucking pavement now. Poor Pikachu, right? But why? How did Pikachu die? Well, it's because this value, right? Right here where he gets attacked. Our Pokemon health points. This value is constantly changing, right? So the first time Pikachu got attacked, he went down from having, you know, 40 health down to 5 health, right? That happened right here. Our Pokemon's health points, which was 40 before, is equal to our Pokemon's health points, which is 40, minus enemy's attack power, which is 35. So now what we're trying to say is that we're saying that our Pokemon health points is reassigned. That value, whenever we reference this value from now on, our Pokemon health points is now a new value. It's whatever is the result of this operation. So now our Pokemon health points equals 5. So that means later on down here, when we say, you know, our Pokemon health points, you know, minus enemy attack power, that means 5 minus 35, which is negative 30, right? So that's how the value keeps changing. We keep on reassigning it, right? We assigned it once up here, and then we keep on reassigning it. Right here it's reassigned to a lower value. And then here it's reassigned again to an even lower value. It keeps happening, and now he's fucking dead. Right? It's sad. Moment of silence, please. Yeah, here goes, Matt. Oh, New Media made it, huh? What the hell did New Media make? Just that one game? When did it come out? I'm sorry for interrogating you. I'm kind of curious. What's up, Apples? I heard Pikachu got excited. I don't know. He got demolished. He got exited from this mortal coil. Okay, but we have a problem, right? I mean, yeah, he's negative. It's whatever. I'm not going to worry about that right now. But our problem is that it's to keep on fighting. We have to keep copying and pasting all this fucking code. Right? We have to keep on copying and pasting over and over again the same code, right? That's wasteful. Why do that? Well, thankfully, in Python and pretty much any other programming language, you can avoid rewriting all your code over and over again, the same exact code, by using what's called a function. Though we've used a couple functions, right? We've used print. We know that print takes one argument, at least, which is what you want to print off. And we've used str, which takes one argument at least. And we know that it's the value you want to turn into a string. Right? So we have these two functions we've been using, print and string. But we can define our own functions. Why don't we do that? So here we've defined some data, right? Let's actually make a new section here. Let's, define some functions. We're going to make our own functions, right? We know we've been using some that are built into Python. We've been using print, which is built in, and string, which is built in. Let's make our own function. So to make it your own function, you have to define it. Right? So def space. That means that's telling Python define a new function, and we can name it. So let's call it, attack. Right? We're gonna make a function called attack. Right? Then we're going to, we're just gonna put some parentheses on behind it, so we know that it's a function, and then we're gonna use a colon, and we're gonna go down a line. So we're defining a new function called attack, and we're going to actually indent 1, 2, 3, 4 spaces. All right. So when you indent code in Python, it means that it only runs in certain circumstances. So far we've only been using code that's right flat against the left side of the screen, right? All this code is right flat left against the side of the screen. That means it always runs, it runs in order from top to bottom, always. But when you indent code in Python, it means it only runs under certain circumstances. In the case of a function, it means that it only runs when you call that function. Like right here, we call print, right? We call string right here. In our case, we're gonna make our own function. And when we call it, we want to have it print off, a string, somebody attacked somebody, right? So that means that whenever we call attack from now on, it will run this code. Otherwise, it won't run. It's going to read from top to bottom. It's going to read this, define Pokemon data, define their enemy Pokemon data. It's going to define some functions, but this code won't run. It won't print this. Not until we call it, because we have the indentation there. What's up, Klaus? He says, tabs versus spaces. We about to go Silicon Valley in this chat. No. No, we're not going to do that. There's no controversy here, dude. Only spaces. Fuck tabs. And fuck anyone that uses tabs. All right, but in all seriousness, though, in Python, it's definitely recommended to use spaces. Some languages, you can use a tab to indent. In Python, please always use a space. In fact, use 4. Okay, so, hey, fuck. We indented our first code, right? So far, all of our code is run from top to bottom all the time. But from now on, our code can actually run conditionally, right? It doesn't always have to run. It'll only run in certain circumstances. So let's implement that. Let's try it. Let's go back down here to the bottom. And fuck. Let's try attack. So here we called print, right, which is a built-in function. We call it all over the place, in fact. Here we use string. We call string right here. It returns a value. It returns a string value from an integer in this case. Now we're calling attack. Now attack does not exist in Python, but we defined it. We made our own attack. Right here. def, that means define a new function. We named it, and we put these parentheses here to know that it's a function. And then whenever you indent lines, you always use a colon first. So that means the previous line used a colon. That means the next line's gonna be indented. And we indented it right there. We have this line of code now. Let's see what happens. I'm gonna clear the screen and run this. Whoa, look it. So here's our old code, right? It ran in order as usual. But look it, it ran in order, but like I said, it didn't actually print this right here. This didn't get printed off at the start because it was indented, right? That means, only run this under certain circumstances. So the first thing it actually does, that we see anyway, is it prints off our Pokemon stats, just like before. Okay. Then, just like before, Pikachu gets a turn, Machamp gets a turn, Pikachu gets a turn, Machamp, and then we ran our attack function at the very bottom, and we got what we wanted. Something happened. It printed off somebody attacked somebody. So here we defined a function that we're calling attack. We can call it whatever the hell we want. We can call it, you know, bleh. It doesn't really fucking matter. We call it whatever the hell we want. And then down here, we ran that function. Bleh. We called it. So whenever you see this code, it means go back up here and run this code. In fact, we can do it as many times as we want. We can go bleh. We can go bleh. We can go bleh. Who cares? That'll always run that code. See, look at it, ran it all 4 times. So Klaus says, Liffy means, can you explain more that string function, please? It means anything in the brackets after string will be converted to a string. Pretty much, exactly. A string is textual data, Luffy. So yeah, a string is just text, but in programming you call it a string. That's really all it is. So let me go back here. So here we have, you know, like an integer. It's like a number, right? These are integers. Here you have a string. So to have a string, you put quotation marks around it. That means it's textual. So here we have, like, you know, we printed off somebody attacked somebody. See these quotation marks here and here? Got the quotation marks on each side. That means it's textual data. That means it's a string. So we're printing off a string here, and here we are assigning a string, and we're making our Pokemon's name a string, Pikachu. And here we're making Pikachu's health points into an integer, 40. So far we've only learned about 2 kinds of data on this channel. Right? It's our first day programming today, guys. We learned about integers, and we learned about strings. So they're the only kind of data we know about. So we have number data, integers, textual data, strings. And when you run this function str, you're saying, we have an integer here, or some other kind of data, but I want it to be used like a string, right? That's what we use the string function for. So in this case, you know, we have our Pokemon's HP is. Now, if we were to add in our Pokemon's health points right there, right? So here's what we have to say, right? We have our Pokemon's name, which is Pikachu. That's a string. Then we add that to a string. So we're saying Pikachu's HP is. Then we're adding in an integer, right? But if we run that code, we get an error. It's a bad scene. Watch, it's gonna fuck up our whole program. Ah, fuck. We got a fucking error, guys. Our code is bugged. What the fuck are we gonna do now? It's a type error. It says you can only concatenate. That means add together. It's programming lingo for add together. You can only add together strings to strings. You cannot add an integer, it says, to a string. So we have an error. You cannot add an integer to a string. So we got to round that, basically. We got to round it by taking this integer right here, and for our purposes, treating it like a string. So str will treat any other kind of data like a string. That's why we're using it there. That way we don't get that error anymore. Because now we're adding in a string right here. We're adding this string to this string, and then we're adding in this string, right? It was, you know, here's the integer version of it, but we're treating it like a string. That's how that works. Cool beans. So let's go back to functions, right? That's pretty fucking exciting, right? We got some pretty cool code here. Isn't concatenate cutting off and append? Isn't concatenate cutting off and append adding to? I'm not sure I understand what you mean, Klaus. Yeah, concatenate just means combining things to my knowledge. I'm not exactly a master of diction, but in my experience, it means you add things together. Concatenate, combine. Synonyms. Okay, so our code is pretty fucking long, but that's because we're running all this code. This code right here is the same exact fucking code as this code right here. So we have the exact same lines of code repeated. Right, doesn't that suck? Like, why do we have to? This makes our code so much longer. But what we found here is that we can actually run the same code repeatedly by calling it as a function. Right here we have this bleh got called 4 times in a row, and it runs the same code right here 4 times in a row. We only wrote the code once. We wrote the code once right here, print somebody attack somebody, and then we ran it 4 times. That's kind of what we got to do right here, right? Kind Kind of reminds you of something right here. Why don't we take all this fucking code, turn it into a function, then we can run it as many times as we want without having to rewrite it all the damn time. Kangaroo Open Board says, what if variable is array or object? What does strung do? Something like JSON stringify. Yeah, kind of, Kangaroo, exactly. Yeah, that's kind of, for you guys that are watching on YouTube, don't worry about it. That's way ahead of where we are in our stream right now. We don't know about arrays or anything yet, or objects. That's for another stream, or maybe later in this stream. But for your information, Kangaroo, yes, it will take a list. In Python, we have lists, not arrays. It'll take a list, and it will turn it into a string. I'll demonstrate it for you. Everybody else, avert your eyes. I want to scare you guys that aren't familiar with lists yet. So if we go to the Python interpreter here, we can do like, print string of a list, 1, 2, 3, oops, let's see here. Right, then we get it just prints it off like that. It just turns into a string that says something like, a pretty good representation of it as a string. Yeah, it's pretty cool. But yeah, basically it'll turn integers directly into strings. It'll turn lists into like a little, it prints off the square brackets and stuff like you would see in an array or a list. It's pretty much like you would expect. Okay, back to business. So what we're talking about right now is function definitions, guys. We have all this repeating code. Can we make this repeating code more economical by only writing it once? Like, I don't want to keep writing like every turn. Like, we can add more turns, right? Let's add another turn just for the hell of it. All right, so let's see here. So for now we have 2 turns going back and forth. We're going to add in another fucking turn. All right, so now our, even though Pikachu's already dead, let's actually make Pikachu not die. Let's actually lower Machamp's attack power. So let's lower Machamp's attack power. Right now he's at 35, that overpowered piece of shit. Make him actually, weaker than Pikachu. Maybe, got tennis elbow or something. You can't Tachigagus anymore all that well. All right, so now we're gonna, go down here and we're going to paste this code. So now we have even more fucking turns. Every turn, basically, our code kind of sucks right now, right? Every turn we take, we have to copy-paste code. If Pokemon worked that way on the Game Boy, can you imagine how huge that cartridge would be if every turn you took had to be its own line of code? That'd be a huge fucking cartridge. But we're going to run it anyway. This is our way right now. We're beginners, so today that's what we're doing. Oops, I didn't mean to do that. I want to run our code. There we go. All right, so there. We got another attack, right? So we got, Pikachu's turn, Machamp's turn, Pikachu's turn, Machamp's turn, Pikachu's turn, and Machamp's turn. All right, so it goes back and forth 3 times. We keep on copy-pasting the code to make it work that way. Let's not do it anymore. Let's make a function out of it. So why don't we go back up here to our attack function. Think of the follow, Luffy. We do programming here on Fridays. Most of the time we're like a gameplay channel. We play a lot of cool stuff like Dark Souls games and retro games like Sonic the Hedgehog and Ninja Gaiden. But on Fridays we program together. We got a new function, right? But we want to run this code. Let's copy paste it. All right, so let's get Pokemon, Pikachu's turn. That's Pikachu's turn, right? We're going to go up here and paste it in. There you go. As you guys know, it's not going to work right now because there's no indenting, right? So we have to say all this code here only runs when we call attack. Right, so we're going to 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Right? Coolio. Sick. Alright, we're actually going to, let's call this Pikachu attack. Okay, and we'll make another function called, we'll call it R attack, right? Because it's not really going to always be Pikachu. It's, we know it's our Pokemon. Then we're going to, define enemy attack. Let's go with that code down here. Use enemy's attack code. I want to warn you guys. We have a bug on our hands already. I'm just doing this for your, for your education, but we're gonna have some problems here. So Klaus says, is it possible to use camel case to name? Yes, you can name your function whatever you want. You can name your function, if you want to, you can call it, enemy attack. You can call it enemy attack. You can call it enemy attack. Attack, 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 1, 2, 3, attack. It doesn't matter. You can call it whatever the hell you want. But it's a good practice in Python, guys, to always name functions lowercase with underscores to separate the words. That's just a practice that programmers use. It won't cause bugs. You can name whatever the hell you want. But if you're going to be sharing your code with other people, which is going to happen one day, trust me, you want to get in the habit of using the Python standard of using function names lowercase with underscores. So class coming from Swift, it feels weird using underscores every time. Yeah, every language has their own standards and practices, right? Again, it won't cause bugs to use different practices, but in Python, to share your code with other programmers, it makes it more sense to follow the standard, which is lowercase with underscores. But again, you can do whatever the hell you want. I'm not your mom. I think the only thing you can't do is start exactly, Kenny. Yeah, you cannot start, like that. And you can't use, let's say, you can't use like, print, or you can't use protected terms that are already used by Python, right? Because print already exists, right? So does string, so does int, a lot of terms, or so does, if, else, while. You cannot use protected terms by Python. You can't start with an integer, but anything else you can do. Even if you want to ignore my tip about keeping it all lowercase and using underscores. All right, so now we have this our attack and enemy attack functions. So let's get rid of all this code down here. It's a bunch of wasted space now. We already have all that code in a much more petite format right here. Now let's try and call these functions. It's not going to work, guys. We're going to try, though. Actually, I think it will work. It'll work once. Here we go. Let's see what happens. No, it didn't fucking work. Okay. So here's our problem, guys. It says our Pokemon health points referenced before assignment. So apparently this is unbound. So apparently Python doesn't know what this variable is, our Pokemon's health points. Well, that doesn't make any sense. Let's go back and look at our code. So right here it says our Pokemon's health points is 40. But when it gets here and tries to run this code, it says it does not know what our Pokemon health points is. Well, how does it not know what our Pokemon's health points is? We defined it right here. Right? That's weird. I'll tell you why it is. Because this code is, it's in a function. It doesn't have access to these values out here. So even though we defined our Pokemon's health points outside of the function, inside of this function, its own little world that it has, it doesn't have our Pokemon's health points. It doesn't know what this is. So that's where the arguments come in, right? Remember our arguments? Remember these? They go between the parentheses, like in print, right? In print, we put all this data between the parentheses. That means we're giving that data to print to use. Right? It says, hey, take this data print and put it on the screen. Remember here on string, we have the string function. It also has an argument, right? Something that goes between the parentheses. And that means, hey, string, take this data and turn it into a string, right? Give me a string back. Right? So we're going to actually make our own arguments for our own function. We're going to give it some data from the outside world. So we're going to say, our attack turn is going to be, we're going to give it, what kind of data do we need? We need our Pokemon's health points, and we need the enemy Pokemon's attack power. We need some Pokemon names, right? And that's it, apparently. Oh, look, I got the wrong order here anyway. This is actually the enemy attack. I'm sorry. Yeah, then we have our attack. See, this is where our Pokemon's health points get reduced right here. And this is where we print off, Machamp, Tachigaiga's Pikachu. So we need all these variables, right? So let's call these like, arg, our health, and like, arg, enemy attack. Well, let's do it like, we'll put in the name first, right? So arg, our name, arg, our health, arg, enemy name, arg, enemy attack. Right? So what that means is we're saying, see these commas? we're saying whenever we use this function, give it this data, right? We have these 4 kinds of data, right? We're naming them ourselves. We're saying we're going to call one of these datas, arg our name. We're going to call the other data arg our health, arg enemy name, and arg enemy attack, right? We need these 4 arguments to run our function. And now we can say, our Pokemon health points is equal to some data we got, right? So we're going to say arg our health minus arg enemy attack. Thanks for the follow, last evac A. Can we do like a mostly gameplay here on the stream? Yeah, I'm talking a little bit fast. Like, I'm going to go refresh you guys in a second here. I'm going kind of fast. This is the most complicated part. This is the most complicated part, I promise. Okay. So, what we're saying now is we're saying when we call this function, whenever we call enemy attack, it needs all this data that we're going to provide for it, right? And when we provide for it, it's like an assignment. So now we have our name and our health and enemy's name and enemy attack. Yes! What's up, here goes? Thanks for the bits, dude. Oh, yes. Yeah, we're a gameplay stream, guys. We program on Fridays here. Don't get discouraged if you see me doing some Zelda or something. We program every Friday. What's up, Substrate? Yeah, I think Echo's not really paying attention to Substrate. He's a friend of mine. He's kind of dipping in and out. All right. Okay, so now we're going to use, these new values we've been given. So we're going to use our enemy name, which we got right here. We're going to use this data we got right here. We're going to use arg our name right here. We're instead of using our Pokemon, we don't have access to our Pokemon name, right? We lost access to this value. That's defined up here. But inside this function, we don't have access to it. But we have this. We have this right here. We have arg our name. We were given that. So let's use that. Arg our name. Okay, we also have our health. Arg our health. Okay. Here goes says, I watched an ad just for an oh yes. There are definitely worse reasons to watch an ad. Okay. It's like he's explaining the situation in the game, pretty much. Alright. So let's go back to basics here. So we're gonna actually just we're gonna only have one function, right? We're gonna only have an enemy turn now. Okay, so we're gonna only have, so here's our code as it exists now, guys. So we define our Pokemon data just like before, right? We define Pikachu's name and his health points, his attack power. We define the enemy's name right here, his health points, his attack power. Right, then we're gonna define a function. We're calling it enemy attack right now, and we're gonna be giving it 4 arguments. Right, so 4 bits of data for it to use. We're saying, hey, listen, do a job for me. Here's the data that you need. Use it how you will. That data, we're going to call it whatever we want. We're calling it arg our name, so argument our name. We're going to call it arg our health for now, arg enemy name, and arg enemy attack. That's what we're calling it for now, basically. First thing we do inside this function is we are, defining our Pokemon's health points, right? We're making that as, let's call something different. Let's call, we're going to call this, for ease of understanding, it's just called arg our health, right? So arg our health, we're subtracting the old arg our health, which is our Pokemon's health there, from the enemy's attack power. So it's the same as it ever was, right? It's like an attack right here. Our Pokemon's losing health based on the enemy's attack power. Then we're printing off that data to the user, just like before. We're saying, his enemy's name, Machamp, Tachi Geigist, Pikachu, exclamation mark, just like before. They're printing off, our name's new HP is our health. So it's the same as it ever was. Let's actually run that code. But we're going to get an error here. Watch. Boom. Okay, so we have a type error. Right? It says the enemy attack function is missing 4 required positional arguments. So what it means by that is this function needs these 4 arguments. And we're giving it nothing. Right? We have a blank spot here. Let's go look at that error again. So it needs arg our name, it needs arg our health, it needs arg enemy name, and it needs arg enemy attack. Well, shit. We gotta fill in some data there, right, guys? So this function cannot do its job without arguments, without some data being fed to it. You got to feed some data in there. So what's for our health, which is in the first slot. Think of it as slots, right? We're going to call this, slot 1, slot 2, slot 3, and slot 4. They're comma-separated slots. The first slot, it needs our name. Well, we have that data, right? Well, we're going to give it our Pokemon name. So in the first slot, we're going to give this thing our Pokemon name. The second slot needs our health. So let's feed it. Excuse me. I can't type right now. Our Pokemon's health. In slot 3, it needs the enemy's name. We know that as enemy Pokemon name. Enemy Pokemon name. Okay. In slot 4, it needs the enemy's what? His attack power. Well, we know that as enemy Pokemon attack power. They actually went a little bit further off the screen there. It's a pretty long line right there, right? Pretty damn long line. So now we've fed in 4 bits of data into its 4 slots. So that means it can now use this data. Let's see what happens. Oh, I fucked something up, guys. It's not our Pokemon health. It's our Pokemon health points. My bad, my bad. So that's going to make this line even longer. Look how long this line is. It's all right. Save it. Run it. Hey, look at that. So it worked. Right, Machamp talked to you, I guess Pikachu. Pikachu lost some health. Okay, so let's review, guys. I know, I've been talking very fast. You guys are probably fucking reeling. So much information. Let's go back to the fucking basics, right? So, first thing we do in our code, define some variables, right? We have a variable name here. We can call these whatever the hell we want. We can call these variables whatever the hell we want. We have an assignment to a string literal. So our Pokemon name, from now on, is equal to some text, says Pikachu. We have more assignments here. We have our Pokemon health points is equal to an integer literal, which is equal to 40. Right? So we have two kinds of data. Textual data called strings, and numerical data we're calling integers, right? Cool beans. We do the same thing for Machamp, right? We have an in Pokemon, he's got a name, he's Machamp. He's got 56 health and 12 attack power. He's pretty weak for a Machamp. We had to lower his health, we wouldn't kill Pikachu. He's out of control. Here we have some code we're going to use again and again. Right, this code is going to be used repeatedly. So we put it into a function. That way we don't have to retype it every single time. Right? But the problem is that this function, it can't use this data we just made. But it needs it, right? It needs it to, do damage to Pikachu. It needs it to print off, how much health Pikachu has and stuff. So we have to feed that data into the function. The way we do that is by defining these arguments up here. And then we use these arguments, as variables in our code. So we're saying, hey, listen, we're going to get our health from the user, from down here, right? We're going to get this data. Now use this data on this line. Our health minus arg enemy attack. So whatever the hell we filled in here, subtract whatever the hell got filled in here. That's what we're saying, right? So whatever got filled in here, our health, right here, subtract whatever the hell the user filled in right here for the enemy's attack power. Right? And down here, we do just that. We fill in the health right here. Then in the 4th spot, right, we have what? 1, 2, 3. Here's the 4th spot. We filled in what it asked for. Enemy's attack power. Cool beans, right? Sech. So now we've fed the function all the data it needs to do a job. Then it does that job. As you can see, it's indented here. All this code is flush with the left side of the screen. That means it always runs. The code will just run from top to bottom, no problem, right? It just runs straight down the line. But if the code is indented, then it only runs in certain situations. In this case, only when this new function it gets called. So all this code right here, this indented code, will only run when we do this. And we can do it as many times as we want. So we've saved a lot of space. In fact, let's do it again. Okay, we're going to actually do it twice. We're going to have Machamp attack 2 turns in a row. What a cheater. Well, I think I need a blank line here. Here we go. Boom. So now we're doing the same thing twice. Now, before we knew how to do functions, We had to copy-paste the code over and over again, which was really a pain in the ass. But in this case, we're just using the function again and again and again. That kind of just saves a lot of work, right? Substrate says, when you say in-game, do you mean if this code actually played Pokemon? Yeah, I think we're all kind of losing track here. Yeah, we're kind of making like a little game here as a way to kind of learn programming. It's a very simple game, though. So don't overthink it. But yeah, so we're running the code twice here. But before we do that, we're printing off our Pokemon stats here. So again, we're going straight down. The code's read from top to bottom. Right? The code's always read from top to bottom. This code is executed. It's on the far left. We're defining all this data. This code is not executed. And we define a new function that's executed. See, it's on the left. So we're defining a new function. But the actual functions code does not actually run until we call it. Then the next thing we do is we show the user our Pokemon stats, right? We print off all of our Pikachu stats and Machamp stats. Here's Pikachu stats right here. Right? Printing it off for the user to see on their side. Then we're printing off the enemy Pokemon stats right here. We're showing the user how strong Machamp is. And then here we actually run our function twice. So the enemy attacks twice. Ah, shit. But we're gonna have a bug, guys. Watch. It's not gonna work like you guys want it to work. I apologize. I'm a shitty programmer. Excuse me. Okay, so hey, look at Machamp attacked twice. That's nice, but Pikachu's health is still 28. He didn't get attacked twice, right? He got attacked once, and then it repeated. He didn't actually lose any health. So why? How come we attacked twice, but Pikachu didn't lose any health? He's still at 28, right? He started off at 40. And he lost 12 he lost 12 HP right here. But then the same shit happened. He started at 40 again, and he lost 12 HP. He's supposed to start at 28. All right, well, let's go look at our code. Okay, so we have some kind of bug here. All right, well, here's our problem, right? Just like the function can't access data from the outside, you know, we can't access like our Pokemon's name unless we get passed it in as an argument. It also can't change data on the outside. So yeah, we say right here, you know, Pikachu's health gets lowered. That's the line where his health's supposed to get lowered, right? But when the function ends, nothing has changed because all this only happens inside the function. You know, what happens in the function stays in the function, right? It's like Las Vegas. So we feed in, like right here, we feed in Pikachu's health, right? Right here, the second argument. Or, you know, you see it right here. Our health. Second argument, second slot. We're sending in Pikachu's health. But when this ends, we do it again. We run the same code twice. But our Pokemon's health points never changes. So it starts off, we feed it 40, right here. Then it, you know, does its thing and ends its code. Then we feed it 40 again. Right? So we're feeding in the same data both times. So that's why it ends up the same result both times. We have to figure out a way to get data out of here. We got to get Pikachu's new health out. So we feed in Pikachu's current health. Then damage gets done. We got to get Pikachu's new health out. So we can feed that into the next time, right? Okay. So how are we going to have this function change data in the outside world? Well, we're going to use a new kind of statement. We're going to use a return statement. All right, so return starts off with the word return, and then you use a space, and then you return the data you want to get out of the function. So in our case, we have what? We have Pikachu's name, his health, the enemy's name, and the enemy's attack power. And once it runs, Pikachu's health changes. Because Pikachu takes damage. So we gotta get his health out of here. So we're gonna say, you know, our health. So we're gonna return this data out. We're gonna say, hey, listen, you lower Pikachu's health. What's Pikachu's new health? Okay. Cool. So now we're getting this data out of here. So what does that mean exactly? Let's run our code again. See what happens. Okay, well, same thing happened, right? Pikachu takes damage twice, but doesn't actually lower his health. So, that's kind of a drag. What's up, Luffy? Says, yo, where can I find your YouTube channel? It's at youtube.com/Vencabot archive. That's youtube.com/Vencabot archive, one word. or just search for Vencabot. I'm the only guy on there by that name on YouTube. It's mostly video games. There is some programming on there, though, some tutorials. Go check it out, dude. I'm very proud of it. All right, so same thing happened, right? Well, that's because when you return data, you have to assign that data to something. Right, here's what I mean by that. We're going to say, let's actually get rid of the second line here for simplicity's sake. So now we only get attacked once, right? We're going to say our Pokemon health points equals enemy attack. Okay. Let me explain what that means. So when you return data, that means you can use this function as part of an assignment. So we're saying, hey, listen, run this code, our function enemy attack, all these arguments, right? Run that code. Then whatever's returned by it, assign it to our Pokemon's health points. Right? See what I'm talking about there, guys? Because this function up here, it lowers Pikachu's health, and then it returns his new lowered health. We're saying, hey, listen, give me that new lowered health, and call it this. Call it our Pokemon health points. Right? So now we can run that code again. Right? So let's actually just take this code here, copy it, and go down. So my ex-girlfriend used to do back in the day. Paste. Okay. Let's just do it again. I'm just going to say, our Pokemon health points. All right. Cool. So now if we go back to this code here, or go back to the command prompt and run it again. Let's actually clear the screen first. Run the code again. Hey, look, Pikachu took more damage this time. So here's what happened, right? So Pikachu had 40 health. Then we ran our function, and he got attacked. He lost 12 health. That's how much attack power Machamp has. Right? Okay, that's cool. But then we got his new health back. And then we used his new health as an argument. So here we say, hey, listen, we're going to feed you Pikachu's old health. Here it is, our Pokemon health points. And then we're getting back his new health. We're calling this one our Pokemon health. Right? We're changing this value, right? We're changing the value of his health from what it was right here to what it becomes right here. And we're doing it all over again. So now we're feeding in the new value right here. Oh, it's kind of complicated, guys. I apologize. We're kind of getting a little bit ahead of ourselves, huh? Cool beans. Okay, so that's all fun and everything, but I can hear you guys. You're saying, Vencabot, Jesus Christ, bro, slow the fuck down. These functions are fucking complicated. What the hell is all these goddamn arguments? What the hell is the return value? What the hell's going on? Yo, thank you, Luffy. Let's make a new program. Right? We're starting from scratch, guys, but it's going to be much simpler. Just to talk about functions real quick. I promise we're going to make some more Pokemon, I promise. We'll get back to Pokemon. But first, let's save this as, function arguments.py. We're talking about functions here, guys. It's very important, but a little bit complicated compared to what we've been doing so far. All right, so we're going to start off with a simple, print, hi, guys. Very simple. Very, very simple. One-line program. Let's go try it. Let's try py. What was it called? Function arguments.py. Oh, it prints off hi, guys. Easy. Easy. One line of code. Now let's put that into a function. All right, so let's make this all go into a function now. We're going to say, we're going to define a function. We're going to call it say hi, guys. It's going to have no arguments. All it does is it says hi, guys. Cool, we have a function now. What happens now if I run this code? What do you guys think's gonna happen? Fucking nothing. Fucking nothing happens. What the fuck? Doesn't do shit. Well, I'll tell you why. Because we defined a function, right? But as we explained before, because the code's indented, it will not run. It only runs in certain circumstances when you indent code. In this case, whenever you call, say hi, guys. So here's what we're gonna do. We're gonna just call it Say hi, guys. There we go. So we define say hi, guys. Oh, I'm sorry, I didn't mean to do that. We defined say hi, guys. We gave it a, some code to run when we call it. And now we're calling it. So now we're going to get hi, guys, right? There we go. In fact, we can even call it a shit ton of times. We can just do it over and over again. That's the glory of making functions, right? The glory of functions, it saves you a lot of space. Because if you have one code, you have one bit of code you're running a lot over and over again, don't bother rewriting it. Put in a function. That makes it a lot easier to call it repeatedly, right? So you can say hi, guys, a bunch of times. Sick, right? Easy peasy. So, let's start talking about our arguments, guys. We're going to make a new function. We're going to call it, we're going to say, add some numbers. We're going to print off 1 plus 3. All right, so now we have this new function called add numbers. Here's what it does. It prints off whatever happens when you add 1 and 3. What's it going to print, guys? What do you think? If you guys can figure it out, you're fucking geniuses. We're going to run this code now, add some numbers. We're going to run it a whole bunch of times, in fact. Sick. If we define a function here, add some numbers, it prints off whatever the hell happens when you get this. When you run this code, what happens, do you think? What do you get from that? 1 plus 3? I don't know. I'm a high school dropout, never learned that stuff. Let's find out. Let's actually clear the screen here. Luffy thinks it's going to be 4. Huh? Let's see if Luffy's right. Hey, Luffy is right. Okay, it prints off 4. 1 plus 3. Yeah, okay, that's 4. Thank you. It's been a while since I brushed up on my math skills. I'm a gamer, not a mathematician. Okay, so Luffy's right. We get 4 out of this. Okay, so we ran it 3 times, prints off 4 3 times. That's cool. But, let's make it a lot cooler, dude. I mean, 1 plus 3 is cool. I like 1 plus 3. I'm not against 1 plus 3. But you know what's fucking sick? Adding in whatever the hell numbers we want. Let's give some arguments, right? Let's say add some numbers. We're going to give it 2 arguments. Number 1. Well, let's call it first number. And second number. So now it needs 2 arguments to work correctly. Right? We're saying, hey, listen, whenever we call add some numbers, give it 2 arguments. They're separated by commas. Oh, before we do, let's answer Echo's question. What if we put in 1 plus 3? Would it say 1 plus 3 then instead of 4? Let's find out. So right now we have 2 integers being added, right? We have 1, which is an integer, and we have 3, which is an integer. Let's try adding in 2 strings. I don't think Klaus is right about that. He thinks it'd be 1, 3. I don't know. I feel like that's probably not what it is. So now we're adding in 2 strings together. Right? What's gonna happen there? I bet you Luffy knows. He's literally a genius. It prints off 13. What the fuck? Since when is 1 plus 3 13? Alright, it's supposed to be 4, right? Well, because we're not adding in... Thank you, Kenny. Yeah, I'm just making fun of you, Klaus. I know. No, Luffy's wrong, yeah. Yeah, it's actually not an error. You can add strings together. You can add strings together. If I could actually add, I could add in, I could say, like, hi, guys. Right? There you go. Hi, guys. Yeah, there's no space. See? It says right there. There's no space. It's 13. But yeah, I can actually, see it says hi, guys there. So when you add strings together, guys, it will combine them, but it doesn't put spaces in. You have to put space in manually. Here's the thing: we could, if you want 1 space 3, you could do this. You could do 1 space plus 3. That'd make 1 space 3. Or you could do, 1 plus space plus 3. All right, that'll make a 1 space 3 print off. Nice. But if you do, when you add 2 strings together, it just adds them right side by side with no space. So here we're adding a string version of 1 and a string version of 3. We get 1, 3. Or 13. It looks like 13, right? It looks like 30, but it's 1, 3. And if we make them back into into integers, it comes out as 4, like Luffy said earlier. There you go. But now let's do some arguments. Let's make this code more dynamic. Right now the code's really boring, right? It always prints off 4. That sucks. Let's make it more dynamic. Let's say we have a couple of arguments now, right? First number, second number. Okay. Well, we're gonna, instead of printing 1 and 3 now, we're gonna print first number and second number. Okay, cool. But what does that mean exactly? Well, now it means when we say, define, we give the function name, we say it needs these arguments now. So this code is bugged now, right? Because of this part right here. Let's actually get rid of all these ones here. This part right here is a bust. It needs data in here, we need data here. Because now we need 2 arguments from now on. So let's give it 2 arguments. We're going to give it, how about like, a 2 and a 6, right? So now what I'm saying is, when you call add some numbers, it needs to fill 2 slots of data, right? See those 2 slots there? We're filling those 2 slots with 2 and a 6. So what we're saying is now first number equals 2, second number equals 6, print first number plus second number. Let's see what happens now. Excuse me. Oh, we got 8. Oh my god. Oh my god. Is it hard to program a bot for Twitch? Hard is relative, Luffy. Hard is very relative. If you're new to Python, it's going to take you a while to learn the basics. If you're new to programming, it takes a while to learn the basics. But once you've learned the basics, it's not really that hard. But if you don't know the basics, it's going to be really hard for you to understand what's going on. But that's what we're here doing today, guys. We're learning the basics today. Okay, so we're kind of talking about arguments here, right? Like, what does an argument mean exactly? Well, basically, you're defining these cool slots. You guys play Final FF7? You have materia slots, right? Well, here we have argument slots. We have 2 of them. And we can use this data we get in these slots inside the function. So we can say, add. We can add some numbers. We can add 5 and 5. We can add some numbers. We can do 10 and 7. So we're feeding in this data into these slots. Then we're using that data in those slots right here. All right. So if we print this, if we show this now, look, we got 8, 10, 17. Right? So we fed in 2 and 6, that's 8. We had 5 and 5, that's 10. We fed in 10 and 7, that's 17. That's pretty fucking sick, right? That's sick. That's way more dynamic now. We can actually feed in data and then do stuff to that data and use that data. All right, that's sick. In fact, why don't we make a new function? Let's say, we're going to say hi to, we're going to make, 1 argument, someone's name. All right, we're going to print off hello plus someone's name, right? So we're feeding in 1 argument now, and we're using that data in that argument to do something cool. So we're going to say hi to, Luffy. We're going to say hi to Echo the Lux. Excuse me. We're going to say hi to, not Echo the Lux, Echo the Lux. We're going to say hi to Klaus. And we're going to say, fuck you to Vencabot. He's an asshole. Don't even hang out with that guy. He's an asshole. What's up, Rash Dog? All right, so let's see what happens here. All right, so we have, we're going to run this code again here. Oh, sick. Look, it actually kind of worked. So it says hello to Luffy. It says hello to Echo the Lux. It says hello to Klaus. Then we get an error there. It says name say fuck you to is not defined. We don't have a function called that yet, right? We don't have that function yet. But hey, look, it worked kind of. We need some punctuation though. It's someone's name plus a period, right? So we say hi to Luffy, we say hi to Echo, say hi to Klaus. Let's run this code here. There you go. It says hello Luffy, hello Echo, hello Klaus. Then it crashes because there is no say fuck you to function yet. Fuck you, asshole. Kenny says, I hung out with them this past weekend. It was fun, huh? Who, me? Yeah, it was a lot of fun, you're right. Okay, so we gotta fix our code. We have no fuck you function. We gotta fix that, right? So let's add that in here real quick. So def say fuck you to, we have, you know, someone's name again. We're gonna print, you know, I love you, plus someone's name, plus exclamation mark. All right, so now we have two functions. Say hi to takes one argument. Then we have say fuck you to someone's name, right? Let's see what happens now. Well, it works now, right? It works. So now we have, you know, 3 hellos and I love you. Nice. Again, the function name doesn't matter, right? The function name doesn't mean anything. We can call it whatever the hell we want, right? It says say fuck you to, but that doesn't mean that's what it does. We just call it whatever the hell we want, right? We can name things whatever we please. That's our prerogative as programmers. We are gods, is what I'm trying to say. Some might take it a little bit too far, but we are. We're gods among men. Worship us. Okay, so here we go. So we have 2 functions now. They both use an argument, right? We feed in data. You can see us feeding the data right here. And then that function can use that data to do something cool. In this case, it prints off a little message for you, right? Pretty simple, but pretty cool. Sweet. So if you go back to our, if I go here, let's go back and look at how this factors into our Pokemon code, right? I want, you know, our Python code here. Where was that? Pokemon Day 1. This code, as you can see, is quite a bit more involved than our say hello to functions, but the idea is the same. We feed arguments to our function, like, you know, the name, like Luffy and Klaus and stuff, like for our say hi to function. We feed in the data, and now we can use that data inside the code. But let's go back to the other simpler code to learn a little bit more before we move on. That would be the function arguments. Okay, so we have this basic code here, right? Take in we find the functions, they have arguments, we use the arguments inside the function to do cool stuff. That's sick. But let's make it even better. Let's not stop there. Let's define, you know, we're gonna make another function here. Let's call it, I don't know, subtract some numbers, you know, subtract some numbers, who cares? We're gonna feed it 2 arguments, a first number and a second number. Oops. We're gonna print off, you know, first number minus second number. Very much like our addition code, right? Then we're going to use that function, subtract some numbers. We're going to say, like, you know, we're going to subtract, you know, 4 minus 1. Right. So you guys with me so far? We have this function here. We defined it. Think for the follow Klaus. We define a function. We start off with the word def. It means, hey, listen, Python, we're making a function. Get ready. Next thing we do is we name the function. Subtract some numbers in our case. We can call it whatever the hell you want. We're calling it subtract some numbers. Then we put in what arguments we need. In this case, we have 2 arguments here in parentheses. They're separated by a comma. The space is optional in Python, but space makes it look neater. Definitely please do that. Then you end the first line with a colon. You always use a colon if the next line is going to be indented, guys. So we have this function definition right here. Define, subtract some numbers, takes a couple of arguments, ends in a colon. From now on, the function's code is indented. All right, so the function code starts right here. Print, first number, second number. That'll only run when you call the function. Down here, the code is no longer indented. Right now, we're back on the left side of it. That means it's not in the function anymore. We could actually add more if we wanted to. Let's add, you know, another line to the function. You just subtracted some numbers you know, you're literally a living legend, right? So all the indented code is part of the function, but as soon as it's not indented anymore, it's now outside of the function. So now we defined a function, and then this code only runs when we, call the function, and then here we call the function. Sick. What's up, dicks? Don't put any colons. Only homosexual men care about colons. Oh my god, dude. I care about colons, dude. I'm gonna be that age. I gotta get my physical. Okay. So let's see what happens now when we run this code. Okay, so it prints off the number 3. Then it prints off, you just subtract some numbers. You're literally a living legend, right? It prints off some messages, some strings, and an integer. Here it prints off an integer, right? The result of a subtraction of 2 integers. And here it prints off a couple strings. 1, 2, and here's where we called the code. Let's actually call it some more. Right? Let's call it again. Let's call, subtract some numbers. Let's say 10 and 5. Right? Subtract 5 from 10. What happens then, do you think? Well, it runs it twice. Right? We get 3 the first time, we get 5 second time. Cool beans. But what if we wanted to take the result of this and then subtract it again? How do we know? I mean, the user knows, right? The user knows that 4 minus 1 is 3. It says it right here, right? They can see that. But how does the program know that it was 3? I want to, let's make a comment here, right? I want to, subtract this, from another number. Well, this is where the return statement comes in, right? We learned earlier that return is how you get data out of a function. We feed data in with arguments. We get data out with return. So we print off some data, right? That's what we do. But let's also return some data. Let's return first number minus second number. Okay. So up here we printed off that data. We printed off, if it's 4 and 1, we print off 3 right here. Then we also return 3. Okay, so that means that now we have access to this number in our program. In fact, we can do it like this. We can say, result equals subtract some numbers for 1. So when you hit this return statement right here, then it spits out that number. And you can assign to that. So now right here, result equals 3. All right. Cool. Now we can say, new result equals, subtract some numbers. We'll retract, result, we'll subtract 5. Okay. Let's see what happens here. I want to load the volume here, guys. I apologize. This song's a little bit loud. Guys, we're enjoying the music of my friend Albdat. He's at albdat.bandcamp.com. Very cool guy. Great composer. His music is free. Go check it out at albdat.bandcamp.com. AUBDAT.bandcamp.com. You're right, Luffy. -3, right? We got 4 minus 1. Well, is that -2, I think? Yeah, 4 minus 1. Yeah, thank you, Luffy, yeah. Yeah, so Luffy's right. So here's what's happening, right? What's going to happen is we get 3 right here. We print it off. Then we return 3. So now, because we're returning it from this, we're spitting out a 3 from this, right? So now we're assigning that to the result. And now we're using result right here. So now whatever this was is getting 5 subtracted from it. And that's spitting out another number, right? That's spitting out, -2. It's going right here. So now new result's going to be -2, right? Now we can say, even newer result equals subtract some numbers. New result, could be minus 10 from it, right? Let's see what happens here. Yeah, so it's negative 12. Yeah, so we got 3, negative 2, and negative 12. Cool. So I showed you guys that because it's so important to understand how data flows into and out of a function, right? You send data into the function with these arguments you can define. That we can use these inside the function, which is cool. And then you can get the data out of the function using return. So here we have, result equals subtract some numbers, 4, 1. We're sending in a 4 and a 1, and then whatever's getting spat out is being assigned to this new variable, result. Right? So now result equals 3, because it shat it out, right? You fed it, and then it shat. Right? We have new result here. We're using our result in the next time we run the code. Cool. All right, guys. Sick. So, why don't we actually simplify this, right? By just reusing the name result, right? So basically, we're going to say, result equals, result equals, result equals. We're going to reuse this name result. So here's what's going to happen now. We're going to feed in this data, 4 and a 1. That's going to become the result. Now we're saying, hey, the new result, right? We're going to reassign the name result. We're going to say the new result is, the old result minus 5. The new result is the old result minus 10. Right? So we're going to reassign. We don't need to make new names. Why bother making a new name? By the order of the Peaky Blinders, huh? Order of operations. Okay. So, let's try this code now. Hey, it still works, right? 3, negative 2, negative 12. Sweet. How guys like that? So where are we going to go from here, guys? I want to talk about loops. So we can keep doing this, right? We'll say, result equals subtract some numbers, result 12, who cares? Result equals subtract some numbers, result 18. We can keep going forever, right? But what if we want it to literally go forever? What am I missing in the chat here? I go talking about order of operations, huh? Let's say 5 plus 7 times 2 is not 12 times 2. It's 5 plus 14. Yeah, the order of operations, yeah. Basic math type stuff. Python respects that as well, by default. All right, so we have this code, and it's pretty repetitive, right? It's really repetitive. In fact, let's make it even simpler. Here's an idea. We're going to say result, it's 4 minus 1. Result equals subtract some numbers, result in 2. Let's do that over and over again. All right, so I'm going to actually copy this code. And then boom, 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 like that. All right. So now every time we're subtracting 2, we're reassigning the name result, right? So we're going to subtract 2 forever, over and over again. Watch what happens here. Okay, let's look at this huge amount of output we got now. All right, we get 3 minus 1 at first, and then 1 minus 2, and then negative 1 minus 2, and then negative 3 minus 2, then negative 5 minus 2. It goes on forever, right? Or quite a few times anyway. And quite a few times there. That's cool. But I have to keep on pasting it, right? If I want to do more. I can paste it forever. Right? We can keep subtracting 2. That's cool. Right, we're down to negative 81 now. I paste it so many times. But you know what we can do? We can make this a lot shorter by using a logical statement. All right, so previously, in all of our code so far, we have, let's do this code here. Let's say, result equals subtract some numbers, 4 and 1 we did before, right? Now, previously, all of our code has been read from top to bottom. It always goes from the top to the bottom, and this code here it's indented, right? It only runs in certain circumstances, right? But what if we want the code to run repeatedly without having to type it in all the time? Well, you can use some logical statements like while true, do this. So here's what we're going to do. We're actually going to say, result equals 10. While true, result equals, subtract some numbers, result and 2. All right. So what does this code mean here? What do you guys think? Well, first of all, we define a function, subtract some numbers. It's got a couple of arguments, right? We know this function by now. We supply a couple numbers, it subtracts them, tells you you're a legend, and then it returns that new value. We know what that does, right? But we have this result. We assign a number to result right off the bat. So right away, result's going to be 10. And then we have this while true statement. It's indented. That means it only runs under certain circumstances, right? It doesn't run necessarily. It always runs only in certain situations. Kind of like how the function worked. But it says result equals subtract some numbers, result in 2. So it'll always give, then even it's not true. It always gives 10. Well, what while true means, it means whatever code follows up after that, run this code as long as the second part is true. Right? Can you show how to get to loop until it goes negative? Yeah, I can. I'll do that next, Kenny. I'll do that next. So if the second part is true, then it'll run, repeatedly. Yeah, Luffy knows what's going to happen. Yeah, so we're going to actually call this false, first of all. So it says, if the second part is true, then run this. Right? But it's false, so it's not going to run, right? Let's see what happens. Nothing happens. Nothing fucking happens. Well, that's fucking boring. But here's what we can do. We can make this code work by changing this part to true. Okay, so now it says, as long as the second part is true, then run this code. All right, let's see what happens now. Oh, shit. Look at it go. Exactly, Irish. It runs forever, right? Shit, let's kill this. I gotta stop it, man. Jesus, I gotta manually kill it. Look how far it got. I got on to negative 363,000 already. Damn, that went fast. But here's why. Because it ran that little bit of code. It ran this code right here as long as this statement was true. But it's true. It's always going to be true, right? It says right there that it's true. So it runs that code forever. That's kind of cool, though, right? I mean, I could do something really cool. Let's try, print, Vencabot is amazing. All right, fuck this. It's going to run forever anyway. Fuck this code. All right, so let's see what happens now. Okay. Sick. Vencabot's amazing. All right, I had to print that off like a fucking 1,000 times. So many Vencabot's amazing. But here's what we can do, right? We're talking about Boolean statements, guys. Uh-oh, what the hell does that mean? I haven't talked about that before, right? What the hell is a Boolean statement? What the hell is a Boolean statement? All right, excuse me, a Boolean value, a Boolean literal, a conditional statement. Like these mean nothing to you guys, right? What the hell are these things? What's a Boolean? Well, a Boolean is a third type of data. We talked about integers, which are numbers. We talked about strings, which is textual data. Booleans are a very simple representation of truth, right? So, a Boolean value is true or false. Right? So right here we have a Boolean. It's our first ever Boolean we've used. Right? We have an integer right here, one kind of data. We have a string right here, that's another kind of data. And we have a Boolean, which is a capital, starts with a capital. It's either true or false. So true is a Boolean, and false is a Boolean. Right? But just like you can add 1 and 1 together, it becomes 2. And you can add, echo the lux and hello together, it becomes echo the lux hello, right? Strings, you can add strings there. You can do operations on booleans, right? They're called conditional statements. You can determine if something is true. So why don't we say, here's what we're going to do. We're going to say, make a new variable. Vencabot is amazing. Equals true. Obviously. How could I not be? Look at me, for God's sake. So while Vencabot is amazing, keep on printing Vencabot's amazing. All right? So what's going to happen here, guys? Well, we have a variable. While Vencabot is amazing. And here we show that that's equal to true. All right? So that'll run that forever. But here's what if we change to false. Okay. Okay. Well, what happens now? Well, now it doesn't run, right? Because now Vencabot's not amazing anymore, which is kind of sad. I don't know who would... That kind of hurts my feelings a little bit, but... Yeah, Vencabot's not amazing anymore. He sucks now. So now we don't print this anymore. That's kind of a pain in the ass. But more than that, you can actually test for a Boolean. It's called a conditional statement. Here's what we're going to do. We're going to go back to our other code. Right? We're going to say result. It does nothing, right? You guys are right. You guys are really smart. You guys are learning, in all seriousness, it's a lot to take in, right? It's pretty complicated stuff. You guys are learning pretty quick. I'm very proud of you guys. Make my life easy as a teacher here. We're going to say, result equals subtract some numbers. Seriously, though. Seriously, this is a lot to take in. I'm talking very fast. I apologize. We're going to subtract result and 2. Remember this code, guys? That was from before. Get rid of this comments. We don't need these comments anymore. Let's talk about, we've done while true. Right? We've done while true, which works. We've done while false, which doesn't work. But what if we did while result is greater than 0? Now, we've done math before, right? We've done, integer plus integer. We've done integer minus integer. We've done string plus string. Yeah, they're case sensitive exactly, Kenny, yes. Yeah, true and false, they're Boolean statements. They're Boolean values. They start with a capital. But now we're doing, math that results in a Boolean value. It returns so right now it says result is greater than 0. All right? So if we read this line of code, here's what's going to happen. Exactly, Echo, exactly, right? He says, I think if you go below 10, it won't do anything. Because result is 10. So it says, while result is greater than 0, well, yeah, it's greater than 0. Run this code. Result equals, subtract some numbers, result in 2. Yeah, Kenny's right too. It subtracts 2 last. Right? So we're saying, now result equals 8. Then it asks the question again. Yeah, you're right, Echo. If it makes it a negative 2, it won't ever run. Right? It won't ever run now. Because it says, hey, while result's greater than 0, well, it's not greater than 0. Nothing ever happens. But if we start with 10, it'll run it once and say, now result is 8. Okay, well, result is still greater than 0. Run it again. All right, now result is 6. Well, is result greater than 0? Yeah. Run it again. Now it comes out as 4, right? All right, well, is result greater than 0? It's still 4. All right, so let's see what happens now. Let's run this program. I think you guys are right. Let's clear the screen here. Well, look at that, guys. So the first thing prints off is 8, because it subtracts 2 from 10. Then it subtracts 2 from 8, then 2 from 6, then 2 from 4. Oh, look, it printed 0. That surprises me. But yeah, so it stops. Yeah, it stops eventually. So the cool thing about a while loop and about conditional statements and Booleans is that you can make your program behave logically. It will actually think for you. I'm gonna sneeze. So basically, conditional statements like this one here, result greater than 0, are how you make your program make decisions. Right? It's making a decision here, right? Based on this information. As long as result is greater than 0, keep on running this code. Yeah, why did it print 0? Let's find out why it printed 0, guys. Oh, yeah, because it becomes 2, right? So it says, let's say this was a result is 2. is 2 greater than 0? Right? Right, Luffy? Let's talk about this. If 2 is greater than 0, it'll run. Right? So it's 2. It says result equals, subtract some numbers. So we have 2 minus 2. Then it prints off 2 minus 2, prints off 0. And then result equals 0. And then it tests it. Right? That's why it prints 0, guys. Because when result is 2, then it runs this. And it prints off 0 right here. That's why. I was kind of confused too. That's how the code is flowing in this case. Kind of part of programming is understanding how the code is flowing and knowing the order things happen in. And it can be kind of confusing, right, Luffy? It can be kind of confusing. But yeah, so it runs it right here. Result is 2 at this point. Then it does 2 minus 2, prints off 0 right here. Then it tests for 0, and then it fails. So we get 0 as the last one. Yeah, Klaus said it prints the last number it stops at, which is 0 in this case. Yeah, because we're printing it off before we're testing for it. Okay, cool. That's fun. So there are other ways to do conditional statements as well, right? Like, for instance, we have a while loop that uses a condition. What about if-then, right? This is my little today's topics, right? We're talking about while right now, right? We also have if and else statements. Now, they also use logic. All right, let's try something like that. So why don't we say, let's get rid of all this text. Let's actually get rid of all these printing. This is kind of confusing. This text is just taking up space, right? Let's try our code here just to get a refresher of what happened. Okay, I took all the fucking text out, right? The living legend stuff. Now it just says 86420. That's a little bit easier to read, right? But now let's, print some more data. Let's say, and let's run this code. Well, no, let's actually run right here. So we're going to say if space result is greater than 5. 1, 2, 3, 4. 1, 2, 3, 4. Again, we see a colon there, means indent it again. Indent it by 4 spaces. Print, we're above 5. Okay. All right, cool. So now we have our second ever conditional statement. All right, so we're running this on a condition. Keep on looping while this condition is true. And then if this condition is true, then do this once. So the difference between an if and a while is while does it over and over again, and if only does it once. So if this is true, print this message, and then do this. All right, let's find out what happens. Run the code. Okay, cool. So we get, we're above 5, then 8. We're above 5, then 6, right? 6 is still above 5. Then 4, 2, and 0. Right? So these ones don't get it. Yeah, Luffy knows what's going on here. So every time this while statement loops, right? It says while is greater than 0, it asks. So every time that this runs, it runs all this code. If results greater than 5, then print this. And then we do the subtract some numbers stuff. Okay. Cool. But see how it didn't actually, so every time it ran this code, it asked this question. Is result greater than 5? And it only does this code if that's true. Once we got down to 4, it kept asking the question, sure, but it wasn't true anymore, so it stopped printing off this message. Wow. 420 echo. 420. Cool beans, guys. So what if we wanted to print another message, though? Well, we could say, if result is less than or equal to 5, print, we're 5 or below. Right? So if it's above 5, it prints off this message. If we're below 5 or equal to 5, it prints off this message. then it does the result thing again. Then we loop all over, start all over again, back up here at the top. Let's see how that operates. All right, so yeah, here we go. So we're above 5, we're above 5, we're above 5 at 6. Now we're at 4, we're 5 or below. At 2, we're 5 or below. Right? Interesting. All right, but here's something, this is kind of redundant, right? Like, why are we testing twice? First, we test if the result's greater than 5. Then we test if the result is less than or equal to 5. Well, we already know if that's true or not, right? Because we know this is true or false. Why ask again if it's true or false? We know that the result is greater than 5, do this. If we didn't do this, then do this. It's the opposite, right? Exactly, Klaus, exactly. That's what I'm trying to say, dude. Like, thankfully, we have an else statement for that. So we can replace if result is less than or equal to 5 with just else. So now it means if this is true, do this. But if it's not, do this. Right? So we're only asking one question now. We're not wasting our time asking redundant questions. If this is true, then do this. If it's not true, or else, do this. That's the same exact code, but only asked a question once, which is, easier on the CPU. Echo says maybe to add something when it falls below. Yeah, that's what we're doing right now. We have this else statement here for that. Let's try this. Okay, so it still works. So I have an idea for another program, guys. Let's do another cool program talking about whiles and ifs and stuff. Let's do, we'll define a new function. We're going to say, say hi to, remember this function? We did this before. Someone's name. Okay. So we're going to say, if someone's name is equal to, use two equal signs there, because we already know that, if we wanted to, say, someone's name equals, David, that uses the one equal sign. So we already have this being used in Python. So we use two for, the question, is it equal to? If someone's name is equal to, Luffy, right? That's spelled like that. Then we print, Luffy to Goud. Then we can say, else print. You ain't Luffy. Fuck off. We only want Luffy, dude. We don't care about anybody else. So now we can, we have this little simple conditional statement, right? We can say, we'll just run, say hi to Luffy. And try this. Okay, so I'm going to clear the screen here. Run this program. Luffy to Goud. Okay, cool. Because we're saying hi to Luffy. It does a test, right? We feed in Luffy as our argument. So we defined our function here. It has one argument, someone's name. We fed that as Luffy. If someone's name is equal to Luffy, print off Luffy to Goud. Right? Otherwise, else, print on, you ain't Luffy, fuck off. Let's try this. Let's try Vencabot. Exactly, Echo. Somebody else doesn't work. Let's try Vencabot. You ain't Luffy, fuck off. Right? Because it only likes Luffy. All right, cool. All right, well, let's make this more interesting. All right, so let's try, if someone's name is Luffy, print Luffy to God. Else, if someone's name equals, Echo the Lux, print off, Echo my dude. Congrats on beating The Last of Us again. Right, so if it's Luffy, if it's Echo, we say, hey, congrats, dude. But if it's not Luffy, right, I said, if it's not Luffy, then ask, is it Echo? Right? So if it's not Luffy, ask, is it echo? Is someone's name equals echo? Then say this. Otherwise, ask if it's somebody else. You know, if it's K. Reich Jr. I misspelled that. Print, it was nice meeting you. Okay, let's do it again. And finally, guys, if it's not, if it's not Echo, it's not Luffy, it's not Kenny, let's print off, fuck the fuckity fuck off. I don't give a shit who you are. All right, so let's look at our code here. So now it says, first of all, is it Luffy? If it is, print Luffy to Goud. If it's not, then ask another question. Is it Echo? If it is Echo, print off this statement. Right? What if it's not Echo? Right? We know it's not Luffy. We know it's not Echo. Well, what if it's K. Reich Jr.? If it's K. Reich, then print off this message. But if it's not K. Reich, well, we already know it's not Echo. We know it's not Luffy, so tell him to fuck off. Right? Let's try this, guys. So I'm putting in Vencabot first. All right, it says fuck the fuckity fuck off. Wow, that's pretty vulgar. Who would program that? What an asshole. Let's try, K. Reich Jr. Exactly, Echo. We can trigger 3 different names now. Hey, it was nice meeting you. So we got Kenny's message now, right? So let's look at the code flow. How is this code flowing exactly? Let's review. So I put in right here, say hi to K. Reich Jr. So first we define a function, right? We define this function. Now this function doesn't run right away. If I don't call, let's actually delete this line right here. We defined a function now and done nothing else. But if we don't call that function, it never runs. Nothing happens, right? Nothing happens. So this code here, because it's indented, it only runs in certain situations. In this case, it only runs if we call the function. Now, what about this line? This line's indented, right? This line's indented even further. Well, that's because it only runs if this is true. This line is indented right here as well. It only runs else. It only runs if this is not true. And as you can see, guys, we keep on indenting and indenting repeatedly, right? We're going deeper and deeper into this logic. This logic is more and more complex. Many questions, asking a lot of questions, right? So we're going to actually get this code running now. We're going to say, to Luffy. All right, now we're calling this code. So when we call this code, we supply Luffy as an argument. We're supplying it right here between these parentheses, right? We're supplying this as an argument, it's called. That argument in the actual function is called someone's name. So we're saying, hey, listen, if they supply an argument called someone's name, if that's Luffy, then do this. If it's not Luffy, if this is not true, then run all this code, right? But first, we got to ask, if they're Echo. If they're Echo, then run this code. If it's not Echo, then run all this code. Right? As you can see, it's becoming more and more complex. Every time we ask another question, we indent further. Eventually, it's going to go way off the screen, right? It's going to be way over here on the far right. We're going in deeper and deeper. Well, thankfully, Python supplies what's called an elif statement. Right? We learned about ifs. That runs if it's true. We ran else, which means, that'll only run if the preceding if statement is not true. Right? So run this if true, else run this. Elif is a combination of else immediately followed by an if. All right, so let's rewrite this code. I'm actually going to copy this code. I'm going to say hi to. We're going to make another function. I'm going to copy paste this code. Okay. So we're going to actually make a say hi to, to. Right? We have another function now called say hi to. It's our second say hi to function. It's exactly the same, except we're going to use elif instead of else if. So we're going to say if someone's name is Luffy, print Luffy to God. Elif, right? So let's actually go down here. We're going to say elif someone's name is Echo the Lux, print that. Elif, someone's name is Kenny, Kenrick Jr., then print that. Else, print this. Exactly, Echo. So by using elif, instead of else followed by an if, we can reduce the amount of indenting we have to do. So that's the glory of elif, is that it's basically the same thing as an else followed by an if, but you have to indent so far. So now we have, if someone's name is Luffy, do this. Else, if their name is Echo the Lux, do this. Else, if it's not, either of those, then do this, if it's Carrie Jr. Else, so the final else has no condition. It's not an elif, it's just else. So, if all this shit above is false, then do this. So say fuck off. Elif is really great if you want to test the same value, like someone's name, against a lot of conditions. Like, if it's this person, right? If you're testing the same value against a ton of conditions, elif is really important. It makes it a lot easier. It makes the code much shorter, much easier to read. Yeah, it's pretty cool, Luffy. Elifs are really, really nice. Echo, there's more to clear, I'm going to put elif, and never goes more to the right. Exactly, Echo, yeah. Said it's the same thing as else if. It's just, you don't have to go any further to the right. So it makes it a little bit more tidy. It's a little bit tidier. Now, because it is what they call syntactic sugar, which means that it's not conveying a new idea. It's the same thing as else if. It just makes it look neater. That means that it's like a Python thing. Other languages don't have that. Let's say you want to learn Java, or you want to learn C++ or something like that. They don't have an elif. You have to keep on adding else and if. But Python is really concerned with appearances and looks, and so it makes it a little bit neater there. ACG says, dude, I'm leaving because I already learned all this stuff in Python inclusive. Nice, dude. Well, pleasure having you. Have a good night. Not sure we've met. Okay, guys. So, that's a lot of fun. We learned a lot of cool stuff. We learned about, assignments, right? We learned about how to assign variables, such as, if I were to do, let's do this. Let's just say, my name equals Luffy. That's an assignment, right, to a variable. They're good stuff, ACG. So we're going to be making some more complex ideas in a future episode on next Friday, probably. Bomberman, it's almost time here, guys. Almost time for Bomberman. Probably so much fun here, though. Could you go over, break it one more time? Oh, yeah, of course, Klaus. We didn't even touch those yet. Let's talk about while and break and continue, excuse me. But yeah, before that, though, let's do this real quick. We're going to review what we've learned today. So we learned about assignments. Right here we have a very simple assignment where we made a variable. It's equal to this string, Luffy. Then we can say hi to with that variable name. Thank you, here goes. I know those bits are very precious to you. I guarantee you we're going to play some Bomberman here very soon. We learned about function definitions, right? We can define our own functions with the def statement, right? Def space followed by the function name. We can name it whatever the hell we want. And we have, some arguments we can use. And then anytime you indent some code, you use a colon before that. So we have, once again, we have here an if statement. Here's a conditional statement. So here's some logical tests. Is this true or not? Right? That's a logical test. It results in a Boolean. So in this case, someone's name is equal to Luffy. This results in true. Right? That's a Boolean value. It returns a colon there. So it means we're going to indent some more. Right? Else statements. You guys know the deal. I'm sorry. I'm kind of repeating myself here. We learned a lot today, guys. Let's talk about break and continue for our friend Klaus before we move on to some Bomberman. Break and continue are special statements that work during loops. There are alternate ways to break out of a loop. Let's go look at that, shall we? So let's do our code again. Let's do def subtract some numbers, first number, second number. Remember this code, guys? We're gonna do. We're gonna return. Let's print first number minus second number. Then we're gonna return first number minus second number. All right, so it's kind of like our code was before. We're going to run while, you know, let's define result. It's going to be 10. We're going to say while result is greater than 0, result equals subtract some numbers, result and 2. Remember this code, guys? So it look very familiar here. All right, so as you guys know, it's going to run this code. It's going to say, you know, 8, 6, 4, 2, then 0, right? Good stuff, Echo. It's a pleasure having you, man. Thanks for stopping by the way, guys. I know it's kind of boring learning programming, but I think it's kind of cool too, right? It's kind of fun to learn. Let's do, you know, what was this code called again? I forgot what this program is called. Function arguments, yeah. All right, so there it is, you know. 8, 6, 4, 2, 0. It runs until while is no longer true, right? So it's boring? Hell nah. I'm glad you guys are enjoying it. So while result is greater than 0, keep on running this code. But there are other ways to break out of code, break out of a loop. Watch, I'm going to actually interrupt this code. We're going to say if result is less than, let's say if result is equal to 4, then we're going to say break. That's it. You're done. All right. So what does this code mean, do you guys think? Well, here's what it means, guys. It means that we're supposed to run the code as long as results greater than 0, right? That's what it says right here. But we are counteracting that by saying, hey, listen, if result is equal to 4, break, stop the loop. You're done. Right? We're interrupting the loop right there. Exactly, Echo. It stops. I think, will it stop? Will it say 4, though? Let me see here. If result is greater than 0, let's say 4 is greater than 0. It'll never say 4. No, it will say 4. It'll say 4. Yeah, okay. Yeah, so let's run it here. Yeah, 8, 6, 4. Yeah. There it is. It stops. We're breaking out of the loop. That sucks. You want to not break out of loops. Let's use our comments. We learned about comments earlier, right? About how you can make Python ignore lines if they start with a number sign. That means Python will ignore those lines now. So now we can run the code again. It should work like we would like. There we go. Yeah, 86420. But we can break out by using the break statement. So now we break at 4. It stops. So that's cool. But there's another cool thing we can do as well. We have a continue statement. Break means end the loop. So let's actually go down here. Let's actually, I'm going to do a quick example for you guys. I'm going to get rid of this code here. And we're going to actually print off a message when the loop is over. So here's how the code flows here, guys. It's kind of confusing for some beginners. First, we start at the top, right? Start at the top, subtract some numbers, right? So we define a function. Then we define a variable called result. Then we run this loop. Then once the loop is over, we carry on down here. What if you say 5 instead of 4? Case says it would never hit 5. I'm trying to understand what you guys mean. We'll do that in a minute, though, guys. I don't think I understand the question. We're going to run this code now. Boom. So yeah, so it says 86420. The loop is over. So once the while loop, this condition becomes false, once this becomes false, then we carry on down here, right? We can also break. We can say if result is equal to 4. I think I understand Luffy's question now. Then we break. Yeah, Kenny's right, though. It would actually never hit 5. I'm going to show you guys why, though. I'm going to show Luffy why in a second. Okay, so look, now the loop is over prematurely. 864, the loop is over. So every time we loop, it asks, is result 4? If result is 4, it breaks. If not, this code never gets run, so we carry on doing this code, right? If it finally breaks, we just jump down to here, basically. No, you're wrong, Echo. It actually won't stop us. I'll show you guys why. Let's say result equals 5, right? Look, it actually goes all the way to the end. 86420. What's up, Austin? All right, guys, so let's use our brains here, collectively. Why doesn't it stop? It goes 86420. It never breaks. If result is equal to 5, then break. Otherwise, result is result minus 2. So I think Echo knows. I think Luffy knows too. Yeah, the reason why it never breaks is because we're subtracting 2, right? So it goes 10, 8, 6, 4, 0. It never is equal to 5. Exactly, Echo. Yeah, it keeps running. It's never equal to 5. Now we could change this to say, if it's less than 5. Exactly, yeah, Luffy, yeah, because it never gives you actually 5. If it's less than 5, then it'll break. We could say less than or equal to 5. That'd be, that would break as well, right? I mean, it never is equal to 5. But it is less than 5. Excuse me, not greater than, less than. So I mean that would be that'd be true eventually, and then we'd break out for sure. But as long as it's exactly equal to 5, then break. It's never going to happen. It's never exactly equal to 5. It's always either a 6 or a 4, right? It never hits 5 exactly, so it never hits to break. But let me show you guys something else that's cool. That bro fist. So let's we know about how breaking works, right? So there are many times where you want to interrupt a loop, right? Let's say that logically you're like, run this loop as long as this is true. But then there's like a really kind of a rare situation where you're like, oh shit, on second thought, let's not run anymore. Right? That's what break is for. Break is kind of like a fail safe. It's like, yeah, run this as long as that's true. But then in a rare case, some shit might go down. Then break out of the code, break out of the loop, right? Get out of it. Because really, we could rewrite this code, right? We could rewrite this as like, while result is, like if we were let's say we would hit like, if result equal to 4, break. Why don't you just say, while result is greater than 4, right? We can get rid of that. I don't need this code here. It's the same fucking thing. It'll have the same result, right? But there are cases in the real world where you do want to break out. What's up, Dixie? Yeah, Bomberman, just not really an event, just something I want to go back to doing. We played it a long time ago for a viewers. It was before Viewers' Choice. It was a random game time slot. I never can think of how we're going to get it back on the show to finish the game. So I figured, since we had no events scheduled, just try that. Just try it, like to play some Bomberman. It's a good game. All right, but let's talk about continue statements. We learned about how break works. Break ends the loop. It just ends it hard. It's like no matter what the hell's going on, no matter what this says, right, whatever the hell this says, just break out right now. The loop is over. But continue is different. Continue says, let's say this, right? Let's just say, if, result is equal to 4, continue. Okay. Now what continue says, it means ignore the rest of the loop and start the loop again. So break says the loop is over, right? Break says, hey, listen, get the fuck out, break out of the loop, we're done. Continue says, skip over this part and go right back to here. Right? So actually the loop continues. The loop keeps going, but it ignores everything after continue. It ignores all this stuff and goes right back to the top and keeps going. So in this case, it would freeze. The program would freeze. Because we say, hey, if it's 4, then go back to here. Is it greater than 0? Yeah. Is it 4? Well, then go back up here. It'd be an infinite loop of going from here to here. So that's, in our program, it's going to cause a freeze. It's not always a freeze. I need to think of a situation where it'd be, not quite a freeze. Let's say, well, let's show the example. I'm going to, print off, result is 4. We're going back to the top with continue. Right? Let's see what happens here. Whoa! Look at it go. It's going forever. I can't even scroll up fast enough. It's going down so fast. All right, let me kill this program manually. So look at all this. Look how many times I printed that. Damn, I printed that a lot. Yo, wait, I can't even scroll up any higher. It just printed it like 1,000 times. Okay, well, let's look at our code. So what happened here was we got this became true, right? So if result equals 4, that became true. Right? So that means it runs this code. It runs this code right here, as long as it's true. But it prints off this message, and then it continues. So if I were to put break right here, it would end the loop hard, and we'd hit this statement. We'd hit loop is over, right? It would break out of this loop. We'd no longer be indented anymore. We'd be down here. But continue means loop again, but ignore the rest of the loop. So it never hits this part. It never hits this part right here. So because we never get subtracted from 4, it's 4 forever, and it loops forever. Klaus says, so continue makes it go back to the top over and over again until it gets fulfilled. Well, yeah, continue actually is just, I can actually, we don't even need an if statement. Like, let's just say, continue, hypothetically speaking, right? I'm actually going to print off, print the loop starts here, right? So I'm going to actually delete this for now. So it prints off, the loop starts here, then we get the result changed. Let's try this. Clear the screen of all this spam. All right, so the loop starts here, 8. The loop starts here, 6. The loop starts here, 4, right? It does all that stuff, and then it prints off the number. So every time it loops, it says the loop starts here, then it does its thing, and then it goes back to the top, right? But if we put a continue in there, continue means go back to the top. No matter what the hell is going on below this, doesn't matter, go back to the top. So this is going to spam the loop starts here forever. Watch. You! So much spam. Kill it. Kill it with fire. So yeah, continue, all it really means is go back to the top of the loop. Just go back to the top of the loop. No matter what's going on below here, go back to the top. So bloop, it goes print, it goes right back to the top every single time. So basically, you could have one like right here, and it wouldn't make any difference, right? Because that is where it would loop, right? It would loop right here normally. So having continue there doesn't really change anything. But you can actually move that around and skip stuff. Sometimes it's important to skip stuff. All right, I'll show you guys an example of that. All right, let's see here. Okay, cool. So yeah, the loop is over. Yeah, it's just normal. Let's actually skip something intentionally. Let's skip something cool. Let's say, I don't want to introduce lists yet. How can I do this without introducing a list? Okay, well, let's say that, 13 is an unlucky number, right? 13 is really a shitty number. So let's say, our result is 20. Right? So let's do this. Let's say, print. I'm actually going to get rid of the statement here. So now, subtract some numbers. All it does, it doesn't print anymore. It just returns this value. Right? So I'm going to print it manually right here. So we're going to print, result. And then we're going to, let's do it like this way. Let's print the result. And then we're going to print. That's a pretty cool number. Right? And then we're going to subtract. Right? There you go. What's that a photo of, Kenny? All right, so here's our new function, guys. So now it subtracts the numbers. It only subtracts. It returns a value, right? It doesn't actually print anything off. We print it off manually right here. So what's going to print first, you guys think? It says, result is 20. While result is greater than 0, print result. So what is the first thing it prints off? You guys think? Oh, it's the brother may have some loops. I love that meme. So we define a function, first of all. Then we define result. Result is, 20. Then we start a loop. The first thing the loop does is it prints result. Right? Okay, so his girlfriend put him up to it, huh? She's a negative influence. It's going to print 20, right? It'll print 20. Then it prints off. That's a pretty cool number. And then the result, we get a subtraction going on here. So we subtract 2 from result, right? That's what happens right here. So we run this function, right? If we run this, it returns this value. The return value is assigned to result again, and then the loop starts over again, right? So let's try this. Okay, so it's 20, it's a pretty cool number. 18, it's a pretty cool number. 16, it's a pretty cool number. Over and over again down to 0, and then it stops. Before it hits 0. So let's go back to our code. But you know what's not a cool number? I'm actually going to subtract 1 right, instead of 2. That way we can get to odd numbers. Let's try this code now. There we go. So now we got 18, 17, 16, 15, 14, 13, you know. That's great. But those are all pretty cool numbers, except for 13. 13 sucks. That's a shitty number, right? So here's what we're going to do. We're going to move this first of all. Okay, so now we print the result, we subtract some shit, then we say it's a pretty cool number, right? Oh no, how am I going to do this? Actually, it's a little more complex than I expected. Let's subtract first. Here we go. So now it starts off saying 19, right? It says 19 first, then we print the result, then we say it's a pretty cool number. Let's try that, first of all, before I change anything around. Let's clear the screen, run the program. Okay, so it starts off at 19, it's a pretty cool number, right? Then it goes 18, 17, 16, 15, 14, 13, all the way down to 0. Then the loop is over, because then we, this becomes false right here, so the loop ends. But if it's 13, right? If result is 13, continue, right? So what happens, guys? If it's 13, it jumps right back up to here again. It skips this part. That's how continue is used. If you want to skip, for any reason you want to skip the remainder of your loop, then that's what continue is for. So if result is 13, we go right back to the top. Fuck anything that happens below that. So now we're going to get, well, you guys know, you're pretty smart. Let's go do it anyway, though. CLS. See, look, so 19, pretty cool number. 18, yeah, that's pretty cool. 17, 16, all pretty cool. 15, 14, 13, nothing. No message, not that cool, right? But 12 was pretty cool, and so was 11 and 10 and 9. That's all great. But here, 13 gets skipped. That's not that cool. That's because right here, if it's 13, we continue, right? We go right back up to here again. We don't ever get to this part if it's 13. See what I mean? Dix likes 13. Okay, well. If it's 13, then, print, at least Dix is cool. Right. But then we continue. We don't print the next one, though. We don't print off as a pretty cool number, because it's really not. It says Dix's opinion. His objectively wrong opinion. Let's see what happens now. That's Echo's lucky number, huh? Okay, well, you guys like 13 then. I guess it's just me. Yeah, so for 13, it skips off the part where it says that's a pretty cool number. It just says at least Dix thinks it's cool, right? So guys, I really expected to do more game programming today, but I think that I got a little bit ahead of myself with the arguments and the return values for functions. This is kind of a lot to take in at once, right? So it's kind of cool, I feel like, that we started off with a little bit of a game, then to explain the ideas like arguments and return values and while loops and conditional statements, if, else, elif, and booleans like true and false. We kind of went to a little simpler program, right? But next week, guys, we're going to work more on an actual game, I promise. It's not just subtracting numbers and stuff. But I have to play some other games now, guys. It's time to end our stream here for Intro to Python as a first language. Thank you guys for hanging out, by the way, though, guys. And thank you, Luffy. Thank you, Klaus, and all you guys for hanging out. Echo, of course. Thank you for the follow, Leo Legit. Again, we're a 40-hour week stream here. We stream for Monday through Friday. It's mostly gameplay, guys. I stream a lot of games. Coming up next is Bomberman 64, a classic from my childhood. But on Fridays, we program a little bit before I start streaming games. So next Friday, we're going to do some more Intro to Python. If you have any questions, guys, definitely ask me anytime. Our Discord server is at vencabot.com. Go check it out. You can go ask me questions there anytime. We have a little channel there called Intro to Python where me and my friends talk about Python beginner basics and share knowledge and stuff. It's pretty cool, guys. If you want to help with the channel, you help out for free by following on Twitch, like all the cool guys like Luffy and all you guys for following today. Thank you guys. Also, you can save clips for free. Get in the chat, come say hi. It's really, really helpful, guys. Makes it a lot more fun for me as a streamer. Again, clips are really cool. They go on my break screen. Not really for programming, but for gameplay. Clips are really great. Also, check out my YouTube channel. It's at youtube.com/Vencabot archive. Or just search for Vencabot on YouTube. You'll find me there. I'm the only Vencabot. We have more streaming of programming over there. Some more tutorial type stuff. As well as lots and lots of gameplay. Lots of modern gameplay and retro gameplay and online games and horror games. Go watch me get spooked if you like. Also, Patreon's a great way to help the channel out. Patreon's a huge support here. Again, I stream for 40 hours a week. When the stream ends, I work on the stream all night long. I'm very passionate about this stream. And so I need to be able to support it financially. Patreon's a huge help. Twitch subs are great. Thank you guys for the Twitch subs. Amazon Prime. If you have Amazon Prime, you get a free sub on Twitch. Don't forget that. It's very helpful around here. Thank you, Klaus. If you guys have any more questions, definitely ask me anytime. Leo says, just started a Python class today at uni. This was a huge help. Of course, Leo says, I'm happy to help, man. At any time, dude. If you have questions with your homework or whatever, check us out on Discord. We can help you with your homework or whatever you want. Echo says, for the YouTube clip, yeah, we have a panel below the stream if you're on a desktop. There's a YouTube panel down there. Patreon's at patreon.com/Vencabot. YouTube is at youtube.com/Vencabot archive. And Twitter is at Vencabot on Twitter. I'm going to go a very short break, guys. Come right back with some Bomberman 64. I will see you guys around. Again, next Friday, same time, guys. It'll be from around 6-ish p.m. to around 9-ish p.m. Eastern time. Exactly, guys. Yeah, Vencabot.com is our Discord channel. Thank you, Kenny, for the reminder. If you go to Vencabot.com, you'll find an invite to the Discord server. We talk about games there, but there is a channel there just for learning Python. Great place to ask questions, share your code, get some tips, help, solve bugs. Come hang out with me and Kenny and the guys. And thank you for follow Leo. Next time, more game design. So we kind of learned some basics today. We're going to probably refresh ourselves next week, get a little refresher, and then start making some cool stuff. Some more interactive stuff. I'll teach you guys about the input function, which makes your programs much more interactive. Damn. He dropped all the way down. Yeah, Dick Zanzu has a week off now every third week. Thank you for the link, Echo. And go check us out on YouTube. I put a lot of work into it. I'm very proud. Echo with the hookups right now. I fucking hit you in the fucking face or like a visceral or some shit. Good, thank you. I know it's kind of weird on mobile. I wish mobile had those panels too, but it doesn't. It's really annoying.
Well, that was
I think they're down there somewhere, but it's kind of hard to access them.